Okay, good morning, everybody. Sorry, we had a few technical things we had to deal with. I'm Pat Swazi. I'm president of the Federation of Vermont Lakes and Ponds, and I want to welcome you to the 2025 Lake Seminar. Thank you all for being here. It's great to have finally the first time since COVID that we've had this in person, or partly in person and partly. So welcome to everybody who's here on Zoom as well. This is a little experimental, so you might have to bear with us through the day as we figure out some of the technical things. So just a few reminders, those folks on Zoom, please stay muted. Please put your comments and questions in the chat. Jackie Sprague, who's sitting over here, our vice president, is monitoring the chat, and she'll read out the questions. In person, if you want to ask a question, we do have a mic. But you'll need to use to ask your questions so that the people on Zoom can hear you. I want to thank the South Burlington Library, this wonderful facility. This is just such a beautiful building that they have here. If there's time for those of you in person, take a walk through the library. It's really gorgeous. And a reminder, no food or drink in the auditorium except water's okay. But don't bring coffee or anything else in here. Okay, without further ado, I'm going to introduce our first speaker, Jenny Austin, who is the program director for DEC's Lakes and Ponds program. Some of you have met her, but Jenny just started in the program in October, so this is her first Lake seminar, and we thought it'd be a great opportunity for her to introduce herself to the wider community. So I will now turn it over to Jenny. Thanks, Jenny.
You just give me a moment to get my bearings here. And speak closer to the mic. Hi, I'm Jenny Austin. It's, as Pat was saying, I did just start in my role back in October, so it's been about 9 months. So I'm still getting to know Vermont. I'm still getting to know my position and getting to know all of you, and it's been really wonderful so far. So thank you for being so welcoming and warm to me. This is also my first Lake seminar. So I'm genuinely honored to be able to kick it off. And I'm really excited to have this opportunity to get to know more of you, do some networking and talk about ways that we can help protect our lakes and ponds. So I think thank you. So to start us off, I just wanted to give you guys some recent highlights of our Lakes and Ponds program, and I'm not probably going to be able to hit on everything. There's so much that we do, but I'll do my best. I know I'm going to kick myself later that I left something important out, but yeah, our program is basically divided into 3 main sections. We have monitoring and assessment, we have aquatic invasive species management, and we also have regulation and restoration.
Click, you have to advance we're not seeing this.
Oh, I'm sorry.
So you have to point it
that.
There you go.
There you go. Now you can actually see what I'm talking about. Sorry about that.
Just looking, I should have left you a handheld microphone.
That's all right. I can talk into this one if that's.
Sounds like that one is having a little bit of audio issues. See if
that's all right.
A little clearer.
Can everybody hear me online? Did you get thumbs up? I can't see the thumbs up, but okay, good. All right. All right. So monitoring and assessment. We have a ton of work going on that supports so much of what our entire watershed management does. Watershed management division. I'm not going to go into it all, just a few highlights, but if this presentation gets posted, all these links work, so you can go and dive into all of there's data available for all these different programs. But to start us off, this spring, our Lakes and Ponds staff sampled core parameters, including phosphorus, nitrogen, and chloride from 67 lakes across the state. And we tried to focus on lakes that are within this year's priority basins, which are the White, Winooski, and Passumpsic watersheds, and then other lakes across the state that we identified. We kind of get together every year at this little monitoring summit, and we identify priorities. We also thought to look at lakes that experienced a lot of flooding last year. So those were kind of what we targeted. And then coming up this summer, the lay monitoring program is going to be sampling over 80 lakes in Vermont for water quality, phosphorus, chlorophyll A, which is indicative of algae and cyanobacteria, and then also caffeine, which is an indicator of wastewater. There's 15 lakes also that we do tributary sampling under the La Rosa program. I'm sure Stacy will talk about that, to inform the lake watershed action plans, which I'll touch on in a moment. But Mark Mitchell, our lay monitoring program coordinator, he's awesome. He's training new volunteers at 5 lakes this summer. He's doing some additional hypolimnetic sampling, which is sampling in the upper portion of the lakes at 3 lakes, and he's also doing some tributary sampling at a couple of lakes. Oh my gosh, I'm so sorry. I am not advancing my slides properly. So going back just for a second, the spring sampling, it's just our spring sampling. That's Dr. Leslie Matthews with the Chemerer, which I learned about. It captures a slice of water where in the water column where you want to collect your samples and do your sampling. So this was actually a picture I took this spring on Bald Hill Pond, and it was beautiful and it was amazing. And then the lay monitoring program, we have quite a few sites all over the state that are really reliant on the volunteers to be collecting this data for us. And I have to say, like, one of the biggest impressions that I've gotten from Vermont so far for just regular communities, everyone is really smart, really has scientific backgrounds, and really actively engaged. And it's just awesome to see that. So all the volunteers that many of you are, it's just amazing to see that, the capability, the capacity that we have, because our program's 15 people. We would not be able to do this. We would not be able to have the data that we have. So the Lake Champlain long-term monitoring. This is, I don't know if you know Peter Isles and Kelsey Colbert from my team. They do their sampling at routine stations around Lake Champlain. It includes continuous monitoring of the Lamoille River mouth using a data buoy, other data buoys deployed around the lake, and then a new data buoy in the inland sea basin where we're seeing kind of a phosphorus and chloride increase. So a lot of collaborative effort for Lake Champlain, multi-state effort. And then some other summer lake assessments. We're about to conduct some point intercepts plant surveys in 5 different lakes, and one of which is Lake Carmi. We want to document how the plant communities change before and after the alum treatment just to make sure there's no issues there. And then our next generation lake assessments are also planned for 14 lakes, which involve comprehensive assessment of the lake's physical, chemical, and biological parameters, and the monitoring of all the significant tributaries within a lake. And then we've got some future plans in the works. We're trying to develop some biocriteria with Tetra Tech and other regional partners, so we can develop these indices of biological integrity for aquatic plants, macroinvertebrates, and diatoms. And we're really hoping that this work will allow DEC staff to develop these biocriteria and put them into our water quality standards so that we can really assess aquatic life use attainment in lakes and the ability to influence the management of our lakes. Sorry, I'm having to advance my notes as well at the same time here. So moving on to our regulation and restoration section. In 2024, our Lake-Wise program performed 171 assessments and gave 84 awards. So again, a very active, awesome community that is voluntarily, in many cases, doing these projects to improve their lake shores. So 2 more lakes received the Gold Lake-Wise Award, Little Averill and Halls Lake. And just so for the folks that don't know, the Gold Lake-Wise Award is given when a lake has 15% of the properties around the lake where individuals have received the individual Lake-Wise awards. So tying into that a little is the Lake Watershed Action Plans. So 2 more lake watershed action plans kicked off in May, Carey and Pilots Bay on Lake Champlain and Sabin Pond, also known as Woodbury Lake. So the Carey and Pilots Bay LWAP is being spearheaded by Friends of Northern Lake Champlain, and Sabin Pond is being done by the Winooski NRCD. And then LWAPs that were recently completed include Seymour and Echo and Fairfield Pond. And then we also have some continuing, when I say LWAP, I mean the Lake Watershed Action Plan work continues at Halls Lake, Woodford Lake, Great and Little Averill, Miles Pond, Lake Bomoseen, and Lake St. Catherine. So another aspect to our regulatory group, and for those of you who don't know, recently we welcomed Laura DeLuca-Leckie into her new role as our Lakes and Ponds Policy and Outreach Coordinator. So she'll be taking the lead on rulemaking efforts for our program, beginning with this next round of revisions that we're planning to make to the use of public waters rules. And there's many other rulemaking efforts that we're hoping to get to eventually. Just for lakes and ponds, it's a lot of proactive stuff that we can do. So stay tuned for more updates on this, but we will very shortly be announcing a public stakeholder process to receive input on our proposed changes prior to even beginning the formal rulemaking. And we will share all of the proposed changes alongside the responses to the individual lake petitions to ban wake sports. And if you check back at this website, this is where we're probably going to be posting a lot of things soon. We're trying to get coordinated. All right. And then also regulatory section now is in addition to all the shoreline protection and lake encroachment permitting that we do, ANC or aquatic nuisance control permitting is now within our regulatory group. So Olin Reed, who's here today, he leads this effort and has been extraordinarily busy this year because a lot of permits that are on a 5 or 10 year cycle just happen to need renewals at this time. So it's a very busy season. Our aquatic invasive species management program has basically 3 parts. We have spread prevention, which is extremely important, most cost-effective way to deal with aquatic invasive species. We have the monitoring and early detection, rapid response. We have, and when basically those 2 methods don't work and you do end up with an introduction, we have the long-term management assistance. And I have 3 more slides. I will be quick. There'll just be less time for questions, sorry. So our public access greeter program trainings have just happened, most of them. We have 1 more June 14th. So, you know, check our website to join up with that. We've trained over 175 people as new and returning greeters, and there are greeters working at 37 water bodies this year. So that's pretty good. We would love to see that grow over the years. And then you guys can check back on all these dates, but these are our Vermont Invasive Patrollers Program trainings. We have lots of lots of them coming up. So Lizzie Gallagher will teach you everything you need to know about how to identify and survey for these aquatic invasive species. And it looks pretty fun. I think I'd like to do on one of these. In our spare time, which isn't much, our aquatic invasive species team started a work group in November to try to come up with some program alternatives for our watercraft inspection and decontamination program. We're hoping to have some long-term recommendations ready for leadership by the fall, but the goals were basically to come up with strengths and weaknesses of the current programs, different alternatives for the summer boating season, and then also a more holistic long-term program for the program. And this is my last slide. I just wanted to tie into the theme of this seminar, which really hits home for me because my career began with streams. For over 12 years, actually, I worked to monitor, protect, and restore stream systems as an aquatic biologist, a watershed restoration planner, and a stream monitoring program manager in Montgomery County, Maryland. So it was in these roles that I really learned how they really are systems. They are interconnected systems. And if lakes and ponds are the heart of the watershed system, then the tributaries that feed into them are like the arteries. They're the arteries and the veins that carry the water and the nutrients to the heart. And don't forget the lungs and the capillaries. Those are all the little headwater streams with the wetlands and the springs and the seeps, which are really critical points of exchange between the groundwater world and the surface water world. And I just wanted to leave you with that analogy, and hopefully it segues nicely into Stacy's and Kelly's presentations and everybody else. But yeah, I can take some questions, I think, now. Hopefully I didn't run over too much. 1 minute.
Yeah, for those of you in the room, if you want to talk, you have to talk in the mic. If you're in the room and you want to talk, you have to talk in the microphone. Otherwise, no one online can hear us.
I'm sorry, I forgot to put my picture up. This is just something I can't remember where I got this from. I think it might be from Margaret Palmer, who's, I don't know if anybody knows who Margaret Palmer is, but she's a big time name in Maryland, and she's where I got my start as an intern way back when. And she, I think, used this in one of her testimonies about the importance of headwater streams and how when you eliminate some of them, it can really cause problems for the whole system. All right, so any questions in the room, or are there any questions online? I can't see any online. I'm happy to answer questions at the end as well. So, okay. Yes. Close that.
So I'll use this. Okay, thanks, Jenny. So this is on.
Oh, I got.
It's on, okay. So thanks so much, Jenny, really appreciate it. And now it's my pleasure to introduce Stacy Pomeroy, who is deep sea river scientist for the Northwest region of Vermont. So
Great. Thank you, Pat. Yes, thank you, Jenny. You did set me up very well. And I actually started my career with the Lakes program. I have many happy memories and hours of driving around the state to meet the lake monitoring program volunteers and get out on their lakes and see the different things. So it is a nice full circle to come back and hang out with the Lakes program. And Jenny did set me up well. So I was asked to kind of talk about some of our stream processes and considerations and really their connections to lakes. So let's see if I can advance. There we go. Okay, so what do I mean by streams, rivers, creeks, ditches? Most of us can maybe think about a perennial stream is a stream that is running year round. Most years, we do have droughty conditions and they may dry in some locations, but most of the time they're running full year. We have intermittent streams, those streams that are typically running part of the year. They're connected to groundwater for some portion of the year, but they may go dry regardless of if we're in drought or not part of the year. And then ephemeral streams are those streams that are really just running when we get a rain event, a snow melt, kind of activity. They're not connected to groundwater. And so really the thing that we want to think about is regardless of what type of stream we have, they all transport water, sediment, and wood when they're running. So that little ditch running down beside your road becomes a stream when it's raining, right? All the same processes that we're talking about play out regardless of the size or type of stream, those same functions. So it's really important, those little streams, those little ephemeral streams we don't often pay attention to, but they still play a role in the stream system.
Stacy, I'm so sorry to interrupt, but we can't see the slides online.
Thank you for letting me know.
Thank you.
I can't help you there, so I'm waiting for a tech person.
Yay, it looks like they're working.
All right, nice, there we go. And can I advance? Which way am I advancing? There we go. Okay, so there are around 417 lakes that DEC tracks, and they're a long list of lakes. I have a subset of around 218 where there was initial work done to look at what are the stream miles in their different categories. So first order, second order, third order, and greater. So on the left of the screen is kind of what a stream order looks like. So those first order are those very first kind of ephemeral intermittent streams that begin to kind of work in, then they become more perennial. When you get two first orders that come together, they become a second order. When you get two second orders that come together, you get a third order. When you get two, we can go on, right? But what's really important is noticing that, as Jenny started to show in her picture, we have a large percentage of those really small first and second order streams. They become extremely important in the network. Oftentimes when we're seeing projects, we're seeing them on the third or fourth or bigger streams. That's where everybody sees the glamour, but it's those small streams that really play an important role as well. Oh, and we have many, many unmapped streams, and we'll look at that in a moment. So out of those 218 streams, I kind of pulled up a couple little stats. Arrowhead Mountain Lake, and Kelly's going to tell me this is not really a lake, but it's kind of a lake. It's kind of a lake in a river, which maybe is why I like it. I also used to live right next to it, so I've paddled it many times. But of those 218, notice that the lake size compared to the watershed size is pretty significant. There is a large percentage, almost 617 miles of first order streams in that watershed that are mapped. And you can see how big, it's almost the entire Lamoille watershed that drains into that. So think of all the land use and the different things that are happening that are really affecting that lake/river area. And then one of our smaller ponds/lake is Half Moon Lake, and that's in Hubbardton, and it has a very small watershed, and it really only has some small amounts of first and second order streams. But in that small watershed, those are even more critical because it's so much is happening to pull it into that little lake. Jenny touched on the lake scorecard or the lake watershed assessment plan. And part of that gets triggered is when we're starting to look at a lake, what's happening in the lake? What are the things that are starting to affect the lake? And so the Lakes program has put together these lake scorecards. We're going to zoom in on Lake Eden. And this is a watershed that has many yellows and a little red. So it's got some maybe concerns or issues. It's got around a little over 3 miles of first order, just around 2.5 of second order, no third order or larger streams, and an unknown amount of unmapped streams. So in the Lake Watershed Assessment Plan, there's shorelines, streams, and roadways that are evaluated. We're going to focus in on the streams in my presentation. And generally, we're focusing on streams that are less than a 2 square mile watershed, and that's typically the first and second order streams for these lake watershed assessments. So this is Lake Eden. The Lake Watershed Assessment Plan looked at the shoreline, the roads. The purple lines on the map on the right are the streams that were looked at. There were 4 blue-lined streams and 1 unmapped stream that were assessed. It was around about 3 miles of stream, I think, that were assessed. So this is what that unmapped stream network looks like in Eden. And when we have the LiDAR now, we can really pick out these types of channels in the landscape. And so the blue lines are a little hard. Let's see if I've got a pointer. Do I have a pointer? Do I have a pointer? Do I know how to... The thing is, do I know how to make the pointer work? Hey, there we go. Look at that. I'm magic. Okay, so this is a blue line stream. That's a blue line stream. There's a blue line stream. This stream is not blue line, but boy, when you look at it in the LiDAR, it has got some pretty distinctive stream characteristics, right? So sometimes what we get focused on is just what has been mapped. But now with the LiDAR and some of the other imagery, we can begin to find areas that weren't mapped. There is a process currently happening to update the streamline in Vermont. It's probably going to be a couple years. They're starting in the Lamoille. That might be out later this year or early next for the updated streamlines. And it'll be interesting to see what new streamlines get captured with that work. So what do we begin to look at in a LWAP for those stream features that we're going to be assessing? Well, part of it is learning about the stream characteristics. So we have a mix of stream types in Vermont and across the world. We have those steep mountain valley streams where they got big rocks and steps and pools moving through. They don't have a lot of shape or sinuosity. All the way down to maybe our wide flat valleys, think coming into Lake Champlain, Lake Otter Creek, big wide flat valley, maybe really fine sandy materials and lots of sinuosity, right? So we begin to just think about what kind of streams do we have coming into the lake? What kind of characteristics might those have? As I mentioned earlier, streams move water, sediment, and wood. And so we're evaluating what type of sediment, how much wood, what's the wood doing, how's the sediment, is there, big rocks, little rocks, fine grain material, what's coming into it, how is the stream holding up to those stream features. And wood is really important because wood actually helps hold, and you can really see it in these pictures. It is helping hold back our sediment in the streams, right? It's a function. It also plays important habitat. So wood looks messy. And my coworker, Will Eldridge, often tells me this is a fish hotel, right? Because it's got all these nooks and crannies, lots of different places, things. And I love the habitat. For me, I'm focusing on, wow, this is lots of roughness in the stream. It helps slow things down. It helps store sediment. It often also helps connect floodplain. As it moves through in the flood stage, it's ramping water back up onto the floodplain, slowing things down, right? So it plays a really critical role in our systems. We're also evaluating what are the things that are interrupting that wood and sediment and water moving through the system. Who here has seen a culvert? Yeah, right? Probably most of you. Who here has seen a culvert that's got perched or has got lots of sediment behind it? Right, yeah, those are pretty good clues that probably that culvert is not the right size for the stream that it's working through, right? Because you're taking something that's wide, and then you're narrowing it down to this little tiny, tiny hole. And the stream is trying to move that wood and sediment like it would on a regular basis, and we interrupted it, right? So we're trying to find out when we're walking the streams, what are the things that are interrupting that, and how is it affecting the stream's characteristics? But it also affects the habitat too, right? No poor little fishy is going to be able to jump 3 feet into that culvert. And even if they could, then there's no water in that culvert for them to get upstream. Or if there is, there's not much water and they've got a long trip up through. We're also paying attention to channel dimensions. So how wide is it? How narrow is it? What does that consider when we're looking at things like velocities or changes in velocities? And really, I teach a river and roads training, and this is a concept of just thinking about if you had in the summertime as a kid a hose that is, kind of garden hose, nothing fancy. And then I have an older brother, and of course in the summertime you always, try to pester your sibling. So you pick up your hose, you put your thumb on the end, and you can get a spray, right? So when we're looking at channel dimensions, we're trying to figure out if we put the same type of, flow through the channel, am I getting more or less power in that channel? And what does that do for the type of erosion we have, the type of sediment movement, the type of wood movement, right? So we're trying to pay attention to the channel dimensions. We're also really concerned and interested about our floodplain connections. How much space is available for the stream to spread out when it has floodplain? And if it doesn't have floodplain, why does it not have floodplain? It could be because we're seeing channel bed erosion. So this is called a head cut. This got started because they chose to dig out the stream. They thought it wasn't holding enough water during rain events, and so they started to dig it out. And what that did was it created almost a 4-foot difference between one part of the bed, a 5-foot difference in the upper part. And what that does is it creates a little powerhouse right there that'll start eroding, and it'll dig and it'll dig, and it'll lose connection to the floodplain. So we're trying to find those things in the stream that might cause a disconnection in the floodplain. We're also scoping out things like slope erosion and bank erosion, or the things that might be causing them. This is a tiny little tile drain, and it created a massive gully in the side of this bank, right? Someone's basement drain, someone's tile drain, someone's stormwater. It gets outletted out at the end of the pipe, and then we don't know where it goes. We just finished. Well, when it goes over a very steep erodible bank, it creates a lot of erosion and issues, right? So we're trying to find out, are there things that we can address? Like once we got rid of this tile drain, then we could address the gully. So how do they work in conjunction with each other? We find lots of infrastructure out there, bank armoring, development pressures, so right up against a stream bank, how are we going to work with that? And lots of culverts and driveway crossings, right? In particular, around our lake shores, we have small streams, and people are trying to get there back and forth across their driveway. So we see lots of these kind of culvert activities. And of course, riparian vegetation. And we want to understand, what's holding the stream together? What's the land use? Is it things that are going to be able to have good root systems really holding on this bank? That tree might be leaning, but boy, look at all those roots that are holding into the bank. Does it have good vegetation that's helping with habitat? Or are we a little scruffy here? This might hold on to some features, but it's not got very deep roots. So what do we have things that we could improve on our vegetation? Who doesn't love a good beaver picture, right? Yeah, so what other natural systems like beavers or other factors might be affecting the streams and contributing to the considerations in that system? And of course, over the last 2 years in particular, we've had a lot of flooding impacts. And so what types of erosion and impacts or changes or or road systems and things coming into our areas have been affected. So that's kind of a brief overview of like where you get out in our lake watershed assessment. We walk the streams. Those are the types of things that we're trying to keep an eye on, document, because that leads us to projects and understanding of the things that we might do towards restoration. And so from the Lake Eden assessment report, they found the most stressors were culverts, bank and gully erosion, a head cut, some bank armoring, and lack of vegetation. And they found that most of the impacts were in the near lake region and less into the upper headwater parts of our streams. And that's because, as you can see from the picture, a lot of our headwater part is still forested. They do have historic impacts and they do have issues in them. They're not issue free, but the bigger stressors and the stressors that we can affect with the work that we do in restoration were more in these areas along the lake shore that we can address with our public. And so what kind of projects were we looking at? Well, and there's some folks in the room here who are going to speak in more detail around some of these things, so I'm kind of setting the stage for them. There's barrier removals like dam removals. Eden doesn't happen to have a dam that's looking to be removed, but we do have lots of undersized structures. So upsizing and correctly sizing our structure improves the stream condition and it improves our aquatic habitat in that area as well. Riparian planting, so really maintaining not just along the lakeshore, but on those stream systems coming into the lakeshore improves the lake condition as well as the stream condition. We don't have any berms on Lake Eden. This happens to be the Lamoille Valley Rail Trail, so if anyone goes biking along that, you'll see some areas where we lowered parts of the rail trail to reconnect floodplain. There's about 200 acres of floodplain that were reconnected in this over several sections of the rail trail that were lowered, excuse me. We also work with folks on doing easements, and we have just found out that there's funding that will support lakeshore easements. So we're going to go rivers, wetlands, and lakes will be the next year's seminar. We'll add in easements there too, right? Because these provide a way for perpetual protection. It provides us a way to have the stream have the ability to move and change over time. It compensates the landowner for the loss of that land, and it allows us to maintain a riparian buffer in that area. And we can do these easements in urban. This is Jeffersonville, where this square was proposed for a large development. This was the flooding in 2011, and the community said, oh, if this gets built out, where does all this floodwater go? It goes into my town. So the town worked really hard with us and fundraised with multiple partners and protected this floodplain perpetually, permanently. We also do a lot in our ag lands. And again, I can't wait to see until we can add lakes up here too. We will also do things like adding back in wood to streams. So I talked about this earlier, the importance of wood in our upper headwater streams, maintaining the connectivity with our floodplains in those areas, trapping sediment, providing habitat, really building the upper stream system. I had beavers. You will hear somebody else speak about beavers today, and so they're going to talk more about some of this work. This is actually Tyler Brown's slide, but really beavers are an important keystone species. They play a really vital role, and we don't want to remove them out of the system if we can help it. And so there are all kinds of different ways of trying to reduce our conflict with them. And so Tyler will speak a little more to that, but we do have ways of maintaining beavers in our system effectively, or we try to. It's also important to note that we have many different types of mapping when we think about flood hazards and different types of impacts to our systems. So the LWAP is a great opportunity to think about roads, the lakeshore, and our streams. It also provides an opportunity, and when I do work in our rivers program, for the community to identify things that are not mapped hazard zones, right? So this is Underhill, just down from me, and there is all kinds of different types of flooding impacts that happen in this community that are not on any type of hazard map area. So a community, you yourself can help identify things that are vital. And so you can do this around your lake as well. The LWAP is a way to help identify those types of things. Also, a community can think about their municipal regulations. They can think about corridor protection. They can think about buffer protection through their regs, through their town plans, and through their zoning. Oop, well, there you go. So when we think about our lake programs, it's similar. We have some of our statewide regulations, but a community can build on that, and they can build on the community's ability around their streams to protect more of those as well. So I'm going to just flip through these quickly, because if this presentation is provided, you'll have an opportunity. Here's some various resources. This is a great way to become familiar with different stream processes. There's a bunch on our rivers page that you're welcome to flip through. Flood resiliency, education, more about our stream work. Agricultural resources, because we do have streams that have ag as part of their watersheds. I love maps and imagery, so here's some great maps and imagery information you can flip back through. Historic topos can be really fun. And then get to know some of your river staff. So we have floodplain managers, river engineers, and river scientists. And then if you have any questions. Good, we can give Kelly plenty of time. All right, we'll trade off. Oh, sorry.
Yes, Stacy. The last couple of years, we've had pretty severe floods in Vermont, and I'm wondering, has the state responded in any way to protect and preserve the headwaters to provide more flood resilience?
There has not been a specific focus on the headwaters as part of the flood resiliency legislation that has been passed, but it continues to be, in past legislation, the regulations for the stream alt engineering changed from a 10 square mile watershed to all perennial streams. That happened in 2012 after Irene, and that does help us provide some better opportunity for oversight on projects and things that happen in that. There's also, with the clean water funding, there's more ability to protect high quality waters, where in the past we've typically been focused on already impacted streams. So there is opportunity to work on those smaller streams that we have not had as much funding and resources in the past. So nothing specific that calls them out, but there are things within our funding and regs that do help us towards those goals more.
Thank you.
Did you have questions? Okay. All right, I'll hand it over to Kelly.
Thank you. Thank you so much, Stacy. This was great. So next up, I am pleased to welcome Kelly Merrill. So Kelly is with DEC, and her focus is on inland lake monitoring. And I think we need to give Kelly a special welcome, because she's actually on vacation, and she's taking time out of her vacation to be with us today. So thank you, Kelly.
All right. Well, thank you, Pat, and thank you, FOVLAP, for going and oh, and I just want to introduce my lovely assistant here,
Vanna White.
Vanna White, Laura DeLugalecki. Part of her new role is to be a support team for me because I am incapable of forwarding my slides on both my notes page up here and on what the people online are seeing. You did fabulous, but it would be really a train wreck up here. So, so Laura's going to be my backup, and I just want to let you guys know, sort of give you a sense of like, I'm really excited you guys are having this as your focus at this meeting. We're boldly going where I don't think FOVLAP's gone before, which is saying something because FOVLAP has done just about every topic possible over the years. So I'm really excited to see us focusing in on headwater streams. One of the things where I became started to really think about this was back in 2011, we started doing these next gen lake assessments where we went around the entire lake shore. We'd spend 2 days, or if we have 2 teams, we would spend 1 day around the entire lake shore and visit every tributary and sample them. And as Stacy was saying, you know, we would be using mapped from the National Hydrology data set, mapped streams. And Dr. Matthews would put waypoints out there and we'd follow them. And sometimes we'd never find any stream there. And then other times we'd find streams that didn't show up on the NHD, and we started sampling them. But one thing that was consistent over the last 15 years that I've been doing this is that we're usually sampling in the summer, and these are really tiny streams. And so then it occurred to me, hey, wonder how many first, second, and third or headwater streams drain into our inland lakes. So excluding Lake Champlain and Lake Memphremagog, sorry guys, from that analysis and excluding all of the dammed reservoirs that are on the Connecticut, because technically those belong to New Hampshire anyway. I asked Sean Regalato, our GIS and our specialist, just like what percentage of streams that drain into our inland lakes are headwater streams. And the number, depending on how you do your rounding, is 90%. 90% are headwater streams that drain into our inland lakes. And as Stacy was alluding to, we don't really have any statewide protection of the vegetative buffers that line those lakes, those streams. And I want to draw your attention to the slide that's going to be behind the background picture that's behind every slide that I'm presenting today. This is, if I can figure out, okay, we're going to advance. All right, except that I'm not advancing. Okay. And so this is Long Pond in Westmore. And we were there in 2018 going around, and you see that little 3 with the big dot next to it. The size of the dot sort of equates to, on our interactive map reports, how big the delta we found is there. And there was no mapped stream coming in there, but we found this stream on Long Pond. Now, Long Pond is one of the oligotrophic lakes in the state with an increasing phosphorus trend. So this kind of input is an important clue as to maybe some problem that might be contributing to those increases in phosphorus. So without further ado, I'm going to now turn to actually reading some of my scripts so that if I ad lib this, we're going to be here all day. So Stacy just gave you a great introduction to the fundamentals of river science, and I'm going to take a moment to review a fundamental part of lake science. And many of you already know this. It's called trophic condition. Essentially, the theory is that most lakes start out as very low nutrient lakes on the left here with very clear waters and little aquatic plant growth on the bottom and little algae in the water column. And then I don't know how to advance my own slides here. Over a long time, like geologic time, sediments and nutrients run off from the lands that drain into the lake, what we refer to as a watershed, and lakes become more nutrient rich and can support more biological organisms, what we call productivity, and the more sediments and nutrients that wash into a lake over time make it more productive. Our clearest lakes with the least amount of nutrients we call the oligotrophic lakes. As nutrients increase and move into what's called the mesotrophy. Then with more nutrient runoff, we head into eutrophy. And then when you get really, really nutrient rich, you get to hypereutrophy. Last year, the United States Environmental Protection Agency published the results of the last National Lakes Assessment, which occurred in 2022. And the US EPA results show that the majority of the nation's lakes are now in the highest levels of nutrient enrichment. 73% of the nation's lakes are now eutrophic or hypereutrophic. And only 19% remain mesotrophic. That's sort of moderately enriched. And then we are down to 7% of the nation's lakes are oligotrophic. The US EPA also found that over just a 10-year period from 2012 to 2022, the nation lost over half of its remaining oligotrophic lakes and almost doubled its percent of most excessively nutrient polluted lakes, the hypereutrophic lakes. So our nation lakes are in a period of rapid change and eutrophication despite 50 years of implementation of the Clean Water Act. The loss of oligotrophic lakes was really first observed and published in a paper by Stoddard et al. In 2016, which was based on the National Lake Assessment results from 2007 and 2012. And they determined we were losing our oligotrophic systems, including streams as well as lakes, on a continental scale. And it was this study that prompted us to look at our long-term data set. And many of you have already heard this story many times before, but for those of you, just want to catch you up if you haven't heard the news. So when we looked at 3 different sets of data, collected 3 different ways that we had collected ourselves here in Vermont, we confirmed that Vermont was as well losing its oligotrophic lakes. So up in the top left-hand corner, we have the long-term spring sampling that just concluded 2 weeks ago. As Jenny said, 67 lakes, wanted to get to 70 lakes this year, but we popped 2 tires, 4-wheeling into a couple Green Mountain National Lakes. So darn, next year. But this is, Ginny Garrison, for folks who've been around a while, know Ginny Garrison, yay, she started this monitoring program in 1977. So we uniquely have a very good long-term data set. In the right-hand corner, you see the lakes that have significantly increasing phosphorus trends. And if it's a blue line, it was an oligotrophic lake in 1980. If it's a green line, it was a mesotrophic lake in 1980. Doesn't mean that's what it still is now. But that was the pattern that we confirmed. We were seeing the same thing that was found in the national level. Because Leslie Matthews is always worried that she's done some sort of analysis wrong. She had to do it 50 million times, and then she had to do it with our summer lay monitoring data. We found the same pattern with that. And then we had our 2007 and our 2012 National Lake Assessment data that was collected with a one-time visit in the summer. We found the same thing that the nation was finding. So yes, Vermont was losing its oligotrophic lakes and some of its mesotrophic lakes. What was interesting, though, is we called up Jeremy Deeds. So Jeremy Deeds used to be one of us. He was working in our program. I still think we try to get him to work for us still, but remotely from Maine DEP. But he sent us the data, the long-term data, over the same period for Maine lakes. And Leslie ran it through her complicated model that Matt can probably talk about later if he wants to, some sort of random forest model or thing like that. But anyway, what was really sort of interesting and sort of shocking was that none of Maine's lakes were significantly increasing. I mean, that red line, and you have to be above that red line to be significantly increasing. So Maine was not losing its oligotrophic lakes or its mesotrophic lakes. So, and that made us sort of think, okay, well, maybe what we're seeing in Vermont, one of our theories was that, it's due to climate change or all these increased storm events and stuff. But what was weird was like, okay, so why is it not happening in Maine? Okay, there's a lot of different things in Maine, maybe geology, whatever. But there's also some sort of management difference in Maine. So Maine has a mandatory shoreline zoning law passed in 1971, which protects, quote, well-distributed stand of trees and other vegetation, end quote, along the streams that drain into Maine's lakes that are greater than 10 acres in size. The vegetation on both sides of the stream, out 75 feet on either side, is protected by that state law. So besides covering more than lakeshore and its protections, Maine's 1971 Mandatory Shoreland Zoning Act works a little differently than Vermont's 2014 Shoreland Protection Act. In Maine, towns are required to adopt local ordinances that protect the vegetation along its stream banks, wetlands, rivers, lakes, and oceanfront. There's a 66-page document put out by Maine's Department of Environmental Protection that gives towns guidelines for the minimum protections they need to afford streams. In this 66-page document, streams are cited 182 times. It provides guidance on setback distances for structures, how to establish a stream protection district, what to do about existing non-conforming structures, and what to do when reconstructing or replacing existing structures, and more guidance. So moving on, in 2017, a seminal paper on the impact road salt was having on the US lakes in the lower 48 was published by a team of lake scientists, with the lead author being Hillary Dugan from Wisconsin. In this paper, they had an interesting graphic which shows the median percent of the land within 500 meters of a lakeshore that is impervious surface for all lakes in the state, 10 acres or greater in size, and that's for all the 48 lower 48 states. In this graphic, the black squares represent the median impervious land cover percentage for each state. You'll notice that Maine has the smallest median amount of impervious surface within 500 meters of its lake shore, and only 16.6% of Maine's lakes have greater than 1% impervious surface within 500 meters of the lake. Whereas Vermont has close to a third or twice as much as Maine, and close to a third of its lakes with greater than 1% impervious surface within 500 meters of the lake. For comparison, 83% of Rhode Island's lakes have greater than 1% impervious surface within 500 meters of the lake. While 1% doesn't sound like much, this paper found that lakes with as little as 1% impervious surface so close to the lake shores is resulting in an increasing salinization or salting of lakes. Ultimately, what this graphic drives home for me is that Maine has less impervious surfaces near its lakes than Vermont does. So it's basically its law since 1971 has been working, which may help explain why Maine isn't seeing the increase in phosphorus in its lakes that Vermont and the rest of the nation are seeing. Now, this is totally speculative on my part. There's lots of other theories that we could go into, but this seems like the most parsimonious explanation to me at this time. So in 2014, Vermont Shoreline Protection Act passed, and while it modeled it on Maine's Mandatory Shoreline Zoning Act, many thanks to David Dean for his many attempts to get a buffer bill passed in this state before that. Thank you for coming today, David, and thank you for all your work in the legislature, pioneering. He put in the buffer bill. We at A&R at some point were not allowed to say the word buffer during a period of time then. It was an interesting time indeed. Sadly, David's bill never did make it over the finish line. But anyway, I digress. See, this is why I cannot go off my script. But anyway, for many reasons. But Maine's Mandatory Shoreline Zoning Act was passed in 1971. But Vermont didn't adopt any of the protections Maine's law affords streams, wetlands, rivers, or to be fair, we didn't adopt them for oceanfront either. But so as I mentioned earlier, 90% of the streams draining into Vermont's inland lakes are headwater streams. By inland lakes, I mean all the lakes greater than 10 acres in size, excluding Lake Champlain and Lake Memphremagog, and the dammed up water bodies in the Connecticut River, as I mentioned earlier. First order stream is the smallest with no tributaries upstream. And when, as Stacy was mentioning, she understands the river science much better, but when two first order streams meet, they form a second order stream. And when two second order streams combine, they create a third order stream. Did I get that right, Stacy? Good, good. Okay. Thank you. Live fact checking. So unlike Maine, the vegetative buffers along these streams are not protected at the statewide level in Vermont. In 2024, the Vermont legislature passed the Flood Safety Act to address development in river corridors and increase protections for wetlands as well. Statewide river corridor protection will go into effect in 2027, 2028 for streams as greater than 2 square mile watershed, which Stacy was mentioning, which will likely include second order streams and larger. But I'm uncertain how those protection will compare to those afforded small streams in Maine. But 53% of streams draining into Vermont's inland lakes are the smallest streams, with no tributaries upstream. And the Flood Safety Act, in my understanding, will not apply to those streams. So let's take a look at what this lack of protection means for one of our inland lakes. I'm going to use Lake Eden since Stacy introduced you all to that lake. And here's the Vermont Lake scorecard for Lake Eden. The lake is shown in yellow on the map, and the watershed is shown outlined in yellow. So everything within the yellow line drains into to Lake Eden. And so here are the flow lines for all the tributaries that flow into Lake Eden. I think it got the one that you were talking about, or did it not? No, okay, it didn't. So using the high resolution land cover that goes down to 0.5 meter resolution that the Lake Champlain Basin Program and Vermont A&R helped fund for the state. So that's pretty unique that we had this high level land use, land cover resolution that goes down to 0.5 meter. And it's because we have that high resolution that we can actually look at what the condition of a 100-foot buffer is. Before that, we were using 30-meter pixel sizes to try to characterize that. And we were oftentimes characterizing our buffers around streams as being more intact than they actually were, and around our lake shore. So it was sort of a big game changer when we got this high resolution land cover data set that the UVM Spatial Analysis Lab put out. And so going down to that 0.5 meter resolution, we can tell what amount of land use within 100 feet of all the streams draining into Lake Eden, except for that stream that's missed, is impervious surface. So bare soil, buildings, and other paved things like driveways, that picks up roads and railroads. So in the Lake Eden watershed, there's 5.6 acres of impervious surface located within 100 feet of a stream draining into Lake Eden, according to that high resolution data set. And here we see 0 acres of agricultural land lie within 100 feet of the streams that drain into Lake Eden, which I think was consistent with what you were saying the LWAP came up with. And then here's the water quality trends as of through 2022 for Lake Eden. So you see in the red in the top right panel, there's a significant increase in total phosphorus occurring in Lake Eden in the summer as measured by our volunteer monitors. So 100% of the streams draining into Lake Eden are headwater streams, and actually they are all first and second order streams. And all total, there are only 6 miles of streams draining into Lake Eden. And here's a map showing the 250-foot shoreline protection zone protected by Vermont's 2014 Shoreline Protection Act for Lake Eden. We see that 19.91 acres, or 13% of this zone, is either impervious surface, and 0% is agriculture. This development concentrated around the lake, as Stacy was mentioning, corroborates what she was mentioning and shows you how the streams around Eden are mostly impacted near the lake. So the importance of streams and lakeshore development is going to vary by lake. So here's another example. This is Lake Salem. The lake is shown in blue on the map, and the watershed is shown outlined in yellow. Everything within the yellow line drains into Lake Salem, a little bit more significant than what we had draining into Lake Eden. So here's the flow lines for all the tributaries that flow into Lake Salem, and using the high resolution land cover layer that goes down to 0.5 meter resolution, we can tell what amount of land use within 100 feet of all the streams draining into Lake Salem is impervious surface. So again, bare soil, buildings, other paved things like driveways, roads and railroads. So in the Lake Salem watershed, 120.5 acres are impervious surface located within 100 feet of a stream draining into Lake Salem. Now it's a big area, but 120 acres of impervious surface being within 100 feet of a stream is still a lot of acres. And here we see that 485 acres of agricultural land lie within 100 feet of the streams that drain into Lake Salem. And here's the trends in Lake Salem through 2022. There's a significant increase in total phosphorus and algae as measured by the pigment chlorophyll A occurring in Lake Salem. 83% of the streams draining into Lake Salem are headwater streams, and 43% of the streams are first order streams. Salem Lake has a lot more streams miles draining into it than Lake Eden, and there are roughly 165 miles of streams draining into Lake Salem, as opposed to only 6 miles draining into Lake Eden. But there is a lot of impervious surfaces in agriculture within 250 feet of Lake Salem too. While the development is established, the Shoreline Protection Act will help buffer this lake from further degradation of the buffer surrounding the lake proper. 16.4% of Salem's lakeshore is impervious surface or agriculture, and 13% of Eden's lakeshore is impervious, just for comparison. So Vermont's Shoreline Protection Act is going to help guide future development of Salem's lakeshore in a manner more protective and of any remaining intact buffers. But the 169 miles of tributaries draining into Lake Salem, with 120 acres of impervious surface and 485 acres of agriculture already within 100 feet of those tributaries, represents a risk to Salem's water quality in the future. So if we're going to build resilience to more frequent extreme rain and storm events for Vermont's inland lakes, the low-hanging fruit would be to begin crafting ways to protect the remaining intact buffers lining our headwater streams and finding ways to restore protective natural vegetation for their already degraded stream buffers in the state. So here's some possible headwater protection strategies that I'll just throw out there. Possibly work with Vermont DEC river scientists like Stacy and the Vermont League of Cities and Towns to maybe craft model ordinances for towns to adopt. Maybe that's something, you know, for those of you who were around before the Shoreline Protection Act passed, our lake scientists worked with staff at Vermont League of Cities and Towns to craft model ordinances for towns to adopt to protect lakeshore. And then when the Shoreline Protection Act came into being, that process ended for the most part. And then the next possible strategy would be develop protection to be afforded to any high quality streams draining into A1 or outstanding resource water lakes, or streams to be reclassified to A1 or outstanding resource water. There are no outstanding resource waters lakes in the state. I'll just mention, that is not because there are not outstanding lakes in the state. They've just gotten sort of gummed up in the whole classification system within over the years. The next thing I'll mention is Streamwise. For those who have okay, and so then for those who are familiar with Lakewise, there's Streamwise, worth looking into. I think that is sort of up and coming. I'm not so familiar with what status that is in. Next, I would say, you know, my personal favorite is look into the feasibility of adapting Maine statewide law to Vermont. And then finally, work with conservation organizations like the River Conservancy, Passumpsic Valley Land Trust, and others to conserve stream front. That's basically a great insurance policy. You know, we're basically buying insurance, and the way we're buying it is buying up some of that stream front, and that is buying insurance for reducing the impacts of future flooding to our lakes. And before I end, I just want to point you to some of the resources. There's the Vermont Lake Scorecard. Many of you are familiar with that. This way you can look up if you just Google Vermont Lake Scorecard, a big table will come up, and you can find a couple of the other resources I'm going to talk about in that table, as well as links to the Lake Scorecard. We're going to have to revamp the Lake Scorecard. Oh, thank you. We're going to have to revamp the Lake Scorecard for a variety of reasons, but I'm optimistic it's going to be even better than the last time, even though it's amazing. Maine DEP copied our Vermont Lake Scorecard, and they've made some innovations that we're eyeing up to hopefully incorporate into ours and make it even better, faster, stronger. And then our next sort of thing I'd like to mention is the next generation lake assessment. So this is what put me on to even noticing that tributaries were so tiny that were draining into our inland lakes, was when we were doing these next generation lake assessments. And so you can find a really cool interactive report that Dr. Matthews has put on the website that you can go into, and you can click on these different characteristics to learn about the measurements we made at the inlets. And you can say, hey, maybe there's some inlets missing that we missed, like like on Long Pond in Westmore. And then there's also recordings, links to recordings, an hour-long version and a 15-minute version on how to use these interactive reports and navigate through them, and sort of how to use them to interpret the information that's there. So there's the 15 minutes tutorial or the 1 hour tutorial, and thanks to Laura Dulugalecki for posting that on. Apparently we have a YouTube channel, so I'm sure you're all streaming that regularly, and that's one of your favorites, but great for upcoming 4th of July parties. I think you guys could watch a few of those talks on there. The next thing I want to mention is the high-resolution land cover summaries. These, I think we have these for most every lake that's greater than 10 acres in the state, and these use that high-resolution land cover and summarize it for the whole watershed, for the 100-foot buffer on either side of all the tributaries, and also for the 250-foot lake protection zone that is around the lakeshore itself. And so you can find those stats for your lakes that if you just sort of poke around in these maps, these high-resolution land cover summaries. And with that, I will just thank you all for your attention, and I'll take any questions. Oh, and thank you, Laura.
Thanks, Kelly. I had a question. Could you give a 1-minute overview of what that next generation lake assessment is? Because my YouTube streaming is not working so well.
Wow, you're like a plant because I have extra slides. In case there were no questions, I was like, well, I need to, share this information with you guys. So thanks for asking that question. So if you go into the next generation lake assessment, this will be the landing page you'll see. And you'll see it says we were at Lake Salem on August 23rd, 2022. You'll see a report card for the lake on the right-hand side. And these are using thresholds that were developed as part of the National Lake Assessment. So you can sort of see, for the northern Appalachian ecoregion, which is the region we're in, it uses the thresholds for that. So you could see how your lake compares to other lakes in the region, and how these scores all compare to that. But you see, this is Salem, which shows you the whole watershed. There's another couple of tabs at the top. And I'm just going to jump us over to the inlets. The water quality tab brings you from the deep hole, this in the deepest part of the lake where all our chemistry is. And then the habitat brings you to a page that gives you a summary of the shoreland condition, the lakeshore disturbance index, the lake shore habitat, and conditions from our 10 random sites that we went around the lake. But this inlet page is pretty fun because you can sort of go you see at the very top right-hand corner, there's 3 more tabs. There's water quality, physical, macrophytes, and outlet. And so in the table on the right-hand side there, you can see some of the data that we collected. We like to observe the top 3 aquatic plants that we see at any inlet because some aquatic plants are really indicative of nutrients, higher nutrients. And so what those species that are really loving that spot can help us understand if maybe there's something going on upstream. So right now I have the sediment delta tab for Lake Salem selected, and you can select any of those tabs that you want. But you can see based on the size of the circle, that tells you we found a delta there, and that tells you, how big it is in comparison to the other deltas that we found around the lake. So you might want to go look upstream of those streams and say, hey, I wonder why there's these big deltas at the end of those streams. Then you can click on the algae percent cover. So something's going on at inlet 5 in that we have some algae growing there. I can't really see what the percent cover is, but you might want to go, anytime you see algae growing at an inlet in Vermont on an inland lake, I would look upstream. It's not really, I don't see it that commonly. So you've probably got a nutrient source coming in from upstream somewhere. And then the next tab is aquatic plants, percent cover. So, some are dump into wetlands and areas and stuff, so you have a pretty good percent cover of plants. But other times that might also be an indicator that upstream there's some nutrient source. The aquatic plants are also going to need a certain type of sediment to grow in. And then the next tab, it brings you to the water. You can go to the water quality page and see the data from that. And here you can see total phosphorus. So it looks like maybe tributary 1 and maybe tributary 6 might be worth looking at. Again, these are just a one-time visit, but and what I want to do is an analysis compared to the La Rosa program when they go they go to a lot of these streams more regularly, not on the Lake Salem, well, maybe on Lake Salem, and start seeing how much our one-time visit can predict what the La Rosa program, multiple visits, are doing, just to get a sense of how much these are like smoking guns. So speaking of smoking guns, this is conductivity. And so I would definitely go take a look at inlet 1 or 2 on this. So the conductivity on that for inlet 1 is like almost 500. It's on inlet 2, it's 542. That's high on Vermont, in Vermont. And so That's not high in other parts of the country. But for Vermont, if you see conductivities coming in there, and you can go back to the water quality page and look at what the conductivity is out in the open water and kind of get a sense of looking at, as you're looking at sleuthing, you say, oh, well, in the open water, the conductivity is only 100. So the conductivity is much higher. So that's like a measure of like maybe dissolved pollutants in the water that's draining into the lake. So you can have some fun poking around in here. I think that might be the end of the demo slides that I put on there. Yeah. Yeah.
There was a question, but it was answered in the chat.
Conductivity.
Oh, sorry. What is conductivity?
Yes, please.
Yeah. So that's a good, is that Peggy? Peggy Barton?
Yes.
Oh, hi, Peggy.
Hi, Kelly.
Yeah, so good question, Peggy. She's a retired school teacher, so she's going to ask the hard questions, you know that. So conductivity, I'm going to butcher describing it, but basically when you see the higher, so when you have really low conductivity in the state, like less than 25 microsiemens per centimeter, which I know you all think in that terms. But when you have that, that's probably indicative you're on an acid impaired water body, a water body that has very low buffering capacity for acid rain, which we do still have lakes that are impacted by acid rain in the state. I mean, they've been doing a great recovery. But so if you have very low conductivity, it equates to being probably an acid impacted lake from atmospheric deposition. If you have very, very high conductivities, that's usually indicated, you can get that, that might be an indicator that you've got road salt impacts coming into that lake, or other types of pollutants that are coming into the lake. In Vermont, roughly most of the lakes, and we could run the stats on this, we have enough data to, I'd say most of the time I see lakes anywhere from 50 to maybe 100 microsiemens per centimeter in the open water. When you get really close to the bottom with our conductivity meter, and you might have anoxic conditions where there's no oxygen down there because the algae in the water column have been really producing, and then they sink to the bottom, and the bacteria in the bottom eat the algae, and then they use up the oxygen while they're doing that. And when that happens, sometimes you can get phosphorus that was bound in the sediments to be re-released into up into the water column again. And conductivity is sort of a cue that might be happening when you put the conductivity measure all the way down there, and it's really like 500 microsiemens per centimeter. So I'm kind of dodging answering the actual what is conductivity and just telling you what it means to me when I see it.
That's helpful. Thank you.
If one is willing to sort of drag yourself through technical details, can you recommend any online watershed modeling tools that would actually predict phosphorus and sediment transport based on precision mapping?
So I'm going to defer that question to Matthew Vaughn. I don't know if he wants to take that or not.
So the question is, are there tools that you can use to try to predict what the phosphorus loading might be to a lake in a storm situation? I think the short answer is no, unfortunately. I'm speaking later, so maybe I'll think about it a bit and see if I can come up with a better answer, but yeah, here.
So I've been playing with one that's been made available by, I think, the Stroud Institute in Pennsylvania. It's called Model My Watershed, and I was just curious whether anyone else has had experience with it, and whether it's reliable.
All right, let me try to do better. So we do have a tool called Stream Stats. Maybe you've heard of it. So you can pick any point on a map, like a lake or the outlet of a stream or river, and you can see information about the watershed. We also have the land cover mapping that Kelly talked about. That's available on Vermont's website. In terms of statewide modeling to predict what might be going to a lake, I'm not aware of anything like that. We do have sector specific models, like we have a program called Farm Prep. So farmers and producers can model the phosphorus leaving their fields and the impacts due to those. There's different models around, but I don't know of one that would model the phosphorus inputs to a lake. We do have analyses and model results for things like that for larger lakes, like Lake Champlain, Lake Carmi, for example, has a TMDL. Lake Memphremagog has a TMDL. So the lakes that have TMDLs will have that modeling done, and the reports are out there, so you can see what is predicted. But in terms of a model where you can click on a point on a map and say, here's what the load is, I'm not aware of that yet. Thanks for the question.
Chris Aquino wants Kelly to please name a few of the aquatic plants that are indicative of growing in high nutrient sources in the sediment.
Oh, that's a good question. So I'm going to dodge that one too, but I'm going to say that Elodea canadensis, when you see that, that's usually a flag for me. And I am going to let you know that ask me that next year at the FOVLAP seminar, because we are developing biocriteria right now using our macrophyte data. We're working with Tetra Tech. Jenny mentioned this in her opening. I am super, super excited about that. I actually have someone in the audience who was very helpful last year in doing our point intercept plant surveys. Fiona Bishop, who now is working with the Lake Champlain Basin Program. Great score, guys. She knows her aquatic plants in and out. But we have now got lots and lots of point intercept surveys from around the state. And Wisconsin DNR has worked biocriteria up using aquatic plants. So biocriteria, for those who are not familiar with, is when you use the biological community to tell you about the health of a lake or a stream, because they are integrators of a stressor. We're there one time taking a Secchi reading, but they're living in this water. So they're integrating all the stressors that are happening. So I'm really excited about where we're going with that. And we're going to be doing that with sediment diatoms, and we're doing it with littoral macroinvertebrates as well. But next year, I will be able to tell you which plants really in Vermont are the best ones to be used as indicators of the higher nutrients, and not just be biased against Elodea canadensis. So thanks for the question, Chrissy. Oh. Okay, sure.
Sorry, quick question. I'm really great presentation. Thank you. Curious how you came up with how you are defining headwaters at the beginning when you said 90% of the streams coming into the inland lakes were headwaters, because I think that's really important in how we think of headwaters. So I was just curious how you were defining it.
Yeah, good question. So they're the first, second, or third order streams. So and the way I'm defining inland lakes is that the data I'm excluding Lake Champlain and Lake Memphremagog. I don't know what the percentage of first, second, and third order streams draining into those actually are, but I'm sure that there's a lot of miles of that too. But I excluded those from that, as well as the lakes that are on the Connecticut River. So it's all the inland lakes that are actually greater than 10 acres. And it's the first, second, and third order streams that drain into those. Yeah, those are the ones. So anything over 10 acres, our Shoreline Protection Act applies to, right, Misha? Yeah, okay. So, and that's where we usually have our data monitoring. Occasionally go smaller, but not really. Okay, thanks, Pat, and thank you.
Any other questions? Thank you so much, Kelly. That was fabulous. Thank you. So we're going to take a break. We'll take about 15 minutes or so. We have some refreshments out in the hallway if you want to help yourself to some coffee and pastries for those of you here. Those of you at home, you're on your own. We'll be back in 15 minutes. Okay, hi everybody. Welcome back. Okay, I got the thumbs up, so I think we're ready to go. So our next speaker is Dr. Elizabeth Duran. Dr. Duran is a research assistant professor at UVM in the Department of Civil and Environmental Engineering. She's an environmental engineer and scientist, and her research includes many things, including energy use and efficiency, and the influence of land use and lake cover on freshwater systems. So I'm very happy to welcome Dr. Duran.
Thank you so much. I think the real theme behind a lot of my research is the way that the built environment impacts humans and nature. And so there is a tie between those two seemingly disparate topics. But today I'm here talking about the habitat function of our floodplains. And the speakers that you've heard already today have teed up this talk so nicely. Some of the slides you will see borrow the same graphics. But what I mean by natural communities, this is an image of a silver maple ostrich fern floodplain forest that I took a couple years ago. And this is my favorite natural community. I don't know why. The silver maples just really, they have my heart. And it's either ostrich ferns or sensitive ferns. The ostrich ferns can be as tall as you are, even if you're 6 feet tall. So that's just a really cool environment to be walking around. And I'm here, obviously I'm here as one person, but the work that I'm going to show you today is really a massive team effort. My UVM collaborators, some of whom you may recognize, Rebecca Deal and Kristen Underwood, James Murdoch and Brittany Mosier are my critter people. And the data that was collected that you'll see by the end of this project was collected by a fantastic team of undergraduate interns. Last year's team, Andrew Chen and Lydia Emery, Ken Johnson and Rose Watts are my field techs, and then cut off on the bottom, Lilo and Maggie are taking over, and they are out in the field, as you'll see, doing a lot of work, collecting a lot of really cool data. But this is a huge project with lots of stakeholders, so we know that floodplains are really important for lots of reasons. This image is from the Otter Creek after the 2023 floods. You can see that there is a lot of water in a lot of places that there is not typically water. So we really want to understand and kind of build the co-benefits of these environments in our watersheds. So like I said, here in Vermont, we have a pretty long history of very altered land use and land cover, which has, you can see here, very agricultural, not a lot of forest cover. We had a lot of straightening and dredging of our river channels for power production and to promote agricultural production. And this history has kind of resulted in a bunch of things that we are now faced with that we might consider challenges. And one of the things that these altered river corridors are really that we're facing is this nutrient problem, which we just heard a lot about. My work has primarily been in the Lake Champlain Basin and has been focused on the influence of land use broadly on the lake water quality. So you can see a harmful algal bloom in that image, but also the influences of the nutrient loading from the landscape. So we know agriculture's a pretty important influence on that nutrient loading, but modeling that's been done, I'm showing you the Missisquoi, roughly 30% of the loading is from this altered stream network. So excessive erosion coming from the stream network as it's trying to kind of reestablish this baseline condition. And that varies depending on the watershed that you're in. So not all watersheds in the Lake Champlain Basin are quite as influenced by the stream network, but some are more impacted by the stream network as well. So you can see the little bar charts. We've also talked a little bit about historic and both modern flooding. And so Stacy's talk about when you get really incised rivers that become more powerful and larger storm events, we can see a lot more erosion and hazards across the landscape. And so we care about these things for many reasons. And so as others have alluded to, we have goals for the Vermont River Network that considers a bunch of different dimensions. The ability of water to connect vertically to aquifers, to access floodplains laterally, and to have passage of water both up and downstream, so longitudinal connectivity as well. And we want to make sure that the stream network and the river floodplains and corridors are protected over time so that they can develop these reference conditions. And so I have been part of an initiative in the Lake Champlain Basin to start, where we are building and developing science to inform decision support in this context. So using these dimensions of the stream and floodplain connection to assess, map, and score the potential and then identify priority projects that we can start to implement in the river corridor, in the river network that will help reconnect rivers to their floodplains and promote a higher level of functionality. And so this is a web-based tool that will hopefully help guide decision-making and is really grounded in work by my colleagues. Rebecca Deal, like I said, and Kristen Underwood have worked to map the extent of the floodplains using probabilistic modeling. So you can see here a floodplain map with the 500-year floodplain. 500-year storms are not that common. You have like a 1 in 0.5 chance every year, though, of having a very large storm like that. And also developing science that can quantify how much nutrients or sediment is captured when we reconnect a river to that floodplain. And so that is helping, you saw this slide already, identify projects where we can actually remove some of the barriers or implement reconnection to promote the better functioning of our floodplains. And so that's all great, but there's a third leg to this stool, and that's the leg that I've really been working on. My colleagues, Roy Schiff and Mike Klein, have been working on the in-stream prioritization projects, but we also value our floodplains and the connection that they have to the river system for the habitat quality that they provide as well. And so the in-stream and floodplain habitat, again, are likely in a departed state because of the way we've managed our land, but we are developing the science essentially to help prioritize using the same hydrogeomorphic baseline condition to inform decision making. So when we think about critters and plants, we want to use a parallel kind of science structure. So we care that critters can move laterally from the river to the floodplains. We care that they can move up and down longitudinally along the river corridor network, and we really want to be able to facilitate and make sure that there's connection to upland environments as well. And we can use these different lenses to help bring a broader stakeholder community to the table to implement these projects that we think are really important. So in order to create this departure and prioritization framework, we started first with looking at the Vermont conservation design. It's already in place. There's been some great work in this space, but the Vermont conservation design identifies the river corridor network as high priority everywhere, which is awesome. Totally true. But that's hard, right? We have so much time, we have so much money, we have so much capacity to implement projects, and so we need a more fine scale resolution in order to help prioritize where to start. And so I was like, oh, well, there's this amazing book, Wetland, Woodland, Wildland, like Natural Communities. It's obviously the next step in the scale down. And so natural communities are assemblages of plants that like to exist, like the silver maple floodplain forest, in particular geomorphic and hydrogeomorphic, in the case of wetlands, settings. And so we are developing probabilistic distribution maps using our existing mapped natural communities and what we understand about them from the experts in the conservation space, as well as our probabilistic inundation maps and geomorphic condition to predict where those should be. Whether or not they are there is a matter of degrees, right? So if they're not there, it's a departure, just like our river geomorphic condition. And we can start to prioritize places where we might like to see them. So sorry, skipping ahead. But are those really, like, how do we continue, how do we build out the prioritization along all of those dimensions that I showed you earlier? And the way that we are both validating these natural community maps and informing our prioritization is by looking at some individual species that are indicators of the actual function of these environments within the river corridor. And so I'm going to show you some really cute pictures from here on out. We are doing a whole bunch of assessment and data collection to help prioritize and build this and build out this tool. So we're using river otters because they like to go into the water and onto the floodplain. They like to eat some stuff that lives in the stream bed, but then they like to socialize up on the floodplain, and they make little slides and they're back and forth. The northern leopard frogs are also a really cool indicator species because they need floodplain pools and forest and the river to be all kind of within a pretty close proximity. River otters can go up to 15 kilometers. The northern leopard frogs have a much smaller range. So we're starting to build out some understanding of how the river landscape is functioning at multiple scales. And we are focused on the Lewis Creek watershed in part because it has a pretty long history of restoration and conservation. So over 30 years of projects and conservation work have gone into this watershed. And there's a really strong landowner network, which in order to do some of this research is really critical. But we can also start to measure if a site was conserved 30 years ago, maybe it's a higher functioning site. That would be the hypothesis, right? So we can start to test that theory to inform, again, our prioritization. So last summer, we set up a network of 49 sites in the Lewis Creek watershed. This is a very small watershed. So every 1.5 kilometers, we have a monitoring site and a lot of very willing landowners participating in this work. And at 49 of those sites, we are conducting a natural community survey. What is growing at this place in the watershed? We are also at each of these sites monitoring the wildlife, mammals. We're doing a passive otter lure because otters are our primary target, but we are expecting to see other things. And then we're also doing inundation monitoring at 6 of those sites. So roughly 4 reaches are monitored for inundation. If there's a flood, we'll know when it happened, how high the water got, and how long it stuck around. And then we're also monitoring at a subset of those sites for amphibians, only where we might see habitat. So if there's like kind of a backwater pool, we're monitoring that pool for the presence of these species. Okay, interruption, sorry. Last summer we had a big flood. I don't know if anyone knows that. But in our watershed, this disrupted our summer plans. Not entirely, but it definitely helped. We had to pivot for a minute. So the Lewis Creek watershed was in the band of highest rainfall total. We had more than 7 to 10 inches in some parts of the watershed. And we were able to get out onto the watershed and capture real-time imagery of the water quality, which you can kind of see in some of these pictures, as well as the extent of inundation. And Kristen Underwood is really responsible for some of this. This is also Cairo-funded work. We're trying to layer our projects. But this storm event was quantified to be a 500-year storm in the headwaters. So huge amount of rain. It was attenuated somewhat to 100 years in the middle of the watershed. And by the time it got to the USGS gauging station at Route 7, it was a 50-year storm. So you can see that there's wide variability in the magnitude of the event within the watershed. And what we have circled here in orange are these extensive wetlands and floodplains within that watershed that were really helping to attenuate this flood peak from the top of the watershed down to the lake. So this is obviously one flood implication for why these environments are really important, and we'll be pulling this kind of information into our habitat modeling as well. Okay, so back to the images. Can anyone find the image, the little critter? You guys are so good. Yeah, so there's a river otter. If that was hard for you, that's okay. We are using AI image processing software to help us look through the 13,000 images that we have collected so far in this watershed just last year to identify the pictures that have critters. And then we are doing an AI/human species level identification of what is in each of those pictures. So the otters, look at those little butts. They're in a few places in the watershed, but they're not in as many places as we were hoping they would be. But that's okay. We've seen a whole bunch of other things, including deer, kind of boring, raccoons, cool, black bears, yeah, moose. Thank you. I know, so charismatic. Bobcats. And actually, we've seen 18 mammals, 18 different mammal species in the watershed. Some of them are everywhere, like those raccoons and white-tailed deer. But some of them are in, just a portion of the sites, black bears, bobcats, coyotes. And then we have a whole bunch of different species who are in a relatively small number of those sites. And of the 49 sites, we also have some variability in the richness of the different species that we're seeing. And so we are in the process of kind of pivoting to thinking about how to use some of these metrics maybe instead of or in conjunction with our target otter species. And so when I say that, what do I mean? So here's a little preliminary occupancy model that we built for the black bear observations using just last summer data. So we have been collecting this data through December, and then we're now starting to collect it again this year. And so when we see a black bear or any other bear, we know it's there, very obviously. But it might be there and we just don't see it, right? So there's some potential missingness. So we have an observed data, and as an example of a correlate that we are interested in, we looked here at just the availability of habitat area. So highly connected native vegetation in the green there at the top within close proximity to each of the cameras. And we can build a little occupancy model, and what you can see here is that black bears, we're seeing them more as the habitat area, we're seeing them more as the habitat area decreases. And so what we think is probably happening is something that you can kind of see in this image, where you have a really nicely connected longitudinal buffer along the stream. This is in the Otter Creek as well. And there is, which is kind of bounded by this disturbed agricultural land that the bears are probably not going to go in. And so when you have that constraint, the bears are more likely to be right next to the river and waltzing by our camera. And so this kind of points to both the importance of the longitudinal connectivity, but also this upland connectivity as well. So we are using this data, and we're still in the process of developing additional kind of modeling using last year's data and the data that we're collecting this year to parameterize and weight the different dimensions here in the prioritization of individual stream reaches. And so this picture is in honor of Lydia, who I have a broken foot right now. She was my intern last summer, and she has graciously stepped in to train this year's students in this work and show them where all the cameras are. And she is an otter enthusiast. And yeah, so I'm happy to answer any questions that you may have, which you may have many. I want to leave that up there though, because it's so cute. So yeah, thanks for your attention.
So I'm a big beaver enthusiast. So I'm interested in two things. Number one, why did you choose the otter over the beaver? And number two, how in your study are you going to treat the impacts of beavers? There's a big story in National Geographic last month about the benefits of beavers to tributaries. So I'm wondering if you can answer those two questions.
Love it. Okay, so beavers could have been an equally relevant species for sure. They are definitely, I'm a beaver believer, so I'm here in the front of the room declaring that in public. And so we picked otters in part, they actually coexist a lot with beavers. Beavers tend to be a little bit more controversial, I think. But the otters will come in and use like abandoned beaver dams as habitat. And so we have been collecting, you know, when we talk to our landowners, we're like taking notes about what they're telling us. And so we are collecting data about beavers as well on the landscape, and the absence of beavers on the landscape. And I think beavers have a more active relationship maybe with landowners than otters do. And so in terms of being able to quantify the presence as an indicator of the environmental condition and less the influence of the human influence on the landscape, because they're sensitive to that interaction, but are not necessarily the target of active management, is really part of that answer. Yeah. And also they're really cute.
Yeah. We have a question from Kelly Stetner. Says, what's the source of that adorable photo of the otter?
The internet.
And one more, what are the two large vertical structures in the picture?
Okay, I borrowed this image. Does anyone? Oh, okay. So yeah, this is the vast bridge on the Winooski River, and this is also from 2011. So this was during Irene, kind of going back a little ways. Again, we've seen a number of kind of larger and larger storm events occurring, and so the importance of this work is consistently reinforced.
Great talk. Thank you so much for everything you're researching there. I think the more that you can bring charismatic megafauna into these things, we can get people to care more about this as well. I'm curious, and I promise on behalf of everyone in this room and online that we will not disrupt your study when you tell us the answer to this, but what are you using to lure these, when you said that you like use some sort of otter lure? We promise not to use that at our own properties and disturb your data set.
Yeah, okay. So we are using a scent lure that we're getting from on the internet from the Minnesota Trap Tagger. So hunters and trappers use scent lures to attract animals, and we are using that same, it's a combination of like gland excretions and whatever other magic they put in it, that attracts the individuals who are within proximity and can kind of smell it to come check it out, see if there's kind of another individual in their home range. But it kind of just washes away and isn't, we're obviously just taking pictures of them. We're not using it to do anything else. Yeah.
Thank you. Also, great talk. I saw in your title, it says something about natural community functions on floodplains for restoration and prioritization or something to that extent. And I was curious about the next steps after maybe another year or so of monitoring. Where do you see your team getting to the point in prioritizing those natural communities to then create and restore?
Yeah, so we are taking the data that we are, so the natural communities maps are going to be one of the variables that we're pulling into these occupancy models, as well as the time since restoration, and the availability and connectedness of kind of upland environments. And we are developing those as methods that will go into this same decision support tool. So they will help us weight the different characteristics that we include in that, so that we can kind of come up with like one number, like start there, right? Or that's a good part of the watershed to either conserve if it's highly connected for habitat function and has mature, like a mature natural community. It can take 100 years for floodplain forests to mature. And so if that exists and it's well connected, we want to make sure that that's protected. So that's that's the direction that we're going. Yeah.
Thanks, Elizabeth. That was great. All right. Switching the technology, still working on that. Thank you so much. That was really, really interesting. Look forward to, hearing more about this project as it proceeds. So our next speaker is Jake Gallinger. Jake is the Riparian Lands Program Assistant for Northwood Stewardship Center, and they're working on collecting native riparian tree and shrub seeds in partnership with the Intervale Center, Vermont Fish and Wildlife, U.S. Fish and Wildlife Service, but I'm sure you're going to talk about all that, right, Jake? Yeah, yeah. So welcome, Jake. So pleased to have you here.
Thank you. Hello, everybody. Thank you so much for the introduction. So yes, my name is Jake Gallinger. I'm here, I am the Riparian Lands Program Assistant at Northwood Stewardship Center. So I'm going to be talking a little bit about our Riparian Lands program at Northwoods, but I'm also going to be talking about our sort of greater Riparian Lands Native Seed Partnership. And I just want to start off with a quick kind of like goal of the Riparian Lands Native Seed Partnership. And basically what we're trying to accomplish through this seed collection and seed saving is the... Oh yeah, yeah. Thank you. What we're gonna be talking about is, or sort of our goal of the project is, we're looking to sort of mass produce floodplain forests for the purpose of fish and wildlife habitat improvement as well as water quality improvement. So how do we do that? Well, this is through our direct seeding project, which begins with us, collecting, processing, and storing native tree and shrub seed species. This is, as it sounds, we are going out and picking berries, and samaras and catkins and whatever we can get our hands on. Whenever we find masting trees or whenever we collect from these masting trees, we keep a track of it on our field maps. We map our seed source locations, as well as a ton of other information, including like the phenology data. We're also working closely with a lot of like local conservation nurseries. We give away a lot of our seeds for free to smaller nurseries. And those go towards propagations and germ testing, but mostly propagations for other conservation projects. And then where all the seeds go, they're gonna eventually end up as part of these direct seeding trials with Vermont Fish and Wildlife, as well as our other partners like the Connecticut River Conservancy. And I'll get into all of that, of course. But also, within the last couple of years, we're trying to do, part of the reason I'm here today, is we're trying to do a lot more education and outreach. We're interested in teaching people about what we do, because you can't really have great science without great science communication. So yeah, so why do we focus on this work? Like we said before, or like I said before, we're looking to improve fish and wildlife habitat, kind of first and foremost. We have a saying, we say fish grow on trees. And what we mean by that is a healthy riparian forest creates lots of habitat for lots of fish that'll end up in our lakes and ponds. Additionally, we're looking to improve water quality. Of course, we'll also end up in our lakes and ponds. And we're also looking to increase our flood resiliency. We're working on a lot of sites that are old ag fields, especially like cornfields, that just have kind of bare soil straight to the bank. So we're interested in buffering that as much as we can. We're also interested in propagating locally sourced trees. So we're interested in keeping genetics that were grown in Vermont. In Vermont, we're not really interested in bringing red maples from Florida up to Vermont. We don't think they're gonna do super well. We're also looking to cultivate a more naturally looking restoration site. And by that we mean, as opposed to something like bare root plantings where the trees are 10 feet apart in like nice, neat rows, kind of like ideal for deer browse. We're looking to create these super, super dense thickets of floodplain forest. And then we also think that this is a cool tool to teach others about riparian restoration. I mean, it's fun to take people out. We take school groups out and lots of other people to pick chokecherries and dogwoods, and we think it's a good tool and we think it's a lot of fun. I'm going to kind of breeze by this, but just to give you guys kind of a scale of the project, this project started almost a decade ago with these cornfield replication experiments, and I'll get into that a little bit later. But this was kind of started by Vermont Fish and Wildlife, the Connecticut Rivers Conservancy, and U.S. Fish and Wildlife. And it wasn't until about 2020 where we decided we needed more seeds for our project. That's when my supervisor, our riparian lands coordinator, was hired. And then again, we needed more help back in 2023. That's when our state seed coordinator, Brooke Fleischman, started. And I will get into them in a minute too. And this year specifically, we're doing kind of a big focus on outreach and education. Here's our team. Like I mentioned before, Brooke Fleischman is the state seed coordinator. She does a ton of work, both on the ground and behind the scenes to make sure that the project goes as smooth as possible. She has an amazing crew. They're back for their second season. That's Reese and Maddie. That's sort of the Intervale Center's crew. But over on the right side, we have our riparian lands crew at Northwoods. And that's my supervisor, Jess Colby. I am her humble assistant of the project. We have also with us today, Gabby, who is our Eco AmeriCorps member and our Northern Water Steward. And for the first time ever, we have Joe here as well, our riparian lands intern. Yes, please give them a round of applause. So this is the Riparian Lands Native Seed Partnership that I was talking about earlier. These are some of the people that have the most involvement from Fish and Wildlife, U.S. Fish and Wildlife, the Nature Conservancy, the Intervale Center is a huge component. Northwoods, as well as the Connecticut River Conservancy. A lot of the seed collection we do comes from Intervale Center and Northwoods, and a lot of the logistics come from the other organizations. So to make a forest, we kind of have to have this diverse array of species that we want to plant. So this is our target species list. These are ones that we like to go out and collect. These are species that are, fast growing, they're water loving, they're really great for riparian habitats. We have like red or dogwood to hold down the bank. We have silver maple to hold down the bank at a much like canopy level. We have cottonwoods, aspens, gray birch to like shoot up and grow really quickly. We have black cherry to fill in the canopy gaps. So these are all things we're kind of taking into consideration when we're looking at our species list, as well as availability. We're looking for things that are relatively easy to collect. And we have a few other species of interest, but they're kind of ones we don't see that often. This is our spring phenology calendar. This is just to give you a look of what we keep track of. We'll go out in April and we keep track of when we see male and female flowers. We're interested in female flowers ideally because these give us seeds. And then you can see that we are right in the heat of our spring collection season. It's a very busy time for us. A lot of things are going at once and a lot of things don't like to wait around for us. A lot of berries will stay on the tree for a few weeks, but a lot of these willows and silver maples, we might lose them if we don't get to them in time. So we are very busy lately, but it's been a lot of fun. And you might be asking yourself, what does seed collection actually look like? And it's as simple as that. We're going out with our big pole pruners and our ladders, and we're picking these silver maple seeds right off the tree, filling our totes with them, and taking them back to be processed. It's a lot of fun. Again, we think it's a cool way to show people like riparian restoration isn't just digging trenches in the dirt. It can be a lot of fun too. Not that digging trenches in the dirt isn't fun. This is our statewide seed source location map. You can see that these are all of our species, and these are all, when we find an area, when we find a masting tree, we'll make a point of it. You can see all the different colors or all the different species. The different shapes refer to whether they fruit in the fall, in the spring, or in the summer. And any of the ones you can see with the blue dot around, or the blue like circle around them, those are ones we've actively collected from. So these are where we're getting all of our stuff from. We keep track of it. We have all kinds of accession numbers and all kinds of other ways to keep track of everything. And we have fridges and freezers full of stuff, all clearly labeled. And everyone else can help us out too, if you're interested. We're always looking for new sites. I mean, we're kind of a small team of people for the whole state of Vermont. So if anybody sees anything, we know that you all are really great botanists. So we'd love to have your help in locating really great sites. We work a lot on state lands, but we could also work on private lands if given landowner permission. So yeah, feel free to help us out if you see a species of interest you think would be a good one to collect from. This is kind of our overview of last season. You can see we collected almost 38 million seeds. I mean, that's a lot of seeds, right? That's 38 million potential trees to grow. And yeah, millions and millions of them have gone onto sites already. And we're looking at even more in the future. We've collected from kind of a wide array last year, 37 different species. So we're hitting our kind of biodiversity quota, so to speak. We have, for the direct seeding experiment, we had 2 sites last year, Johnson Farms up in Canaan, and a site on the Upper Lamoille in Wolcott. And we also have thousands of propagations started at ICN through the help of the Conservation Nursery. These are some of our seed cleaning techniques. I just wanted to give you guys an idea of like what we do with them once we've collected them. I have a couple of videos. I hope they're not too loud and I hope they actually work. But we can see if that actually happens. This is kind of our summer cleaning procedure. This is what we do to clean berries like dogwood berries and choke cherries. This is our Divvig seed cleaner. It's basically a combination between a washing machine and a food processor. And it basically just gets rid of all the flesh on the berries. That's perfect. Yeah, so you can see we're just putting water in there to like lubricate the seeds and make sure they're not getting too dried out and scarified. And that's our summer collection sort of equipment we use. That's for our berries. This is our spring cleaning. We collect a lot in the family Salicaceae, so they produce this like really like fluffy material right here. And you can see the difference between our cleaned seeds and our uncleaned seeds, just how much space we're saving when we store these by cleaning it down to this like degree. We're also getting a much more accurate count on how many seeds we're collecting. And this is our quaking aspens, our balsam poplars, black willows, shrub willows. And this is our method. This is our tried and true method. We call it the tornado method, where we basically blast highly compressed air through a bunch of gold panning sieves through this like dog water container up here. And you'll see how that works in a second. This is our Northwoods Conservation Science Director, Meg Carter. You can see we have some seeds getting stuck in there. And then we have a lot of seeds in this bottom container as well. Also, we did the math recently. We think that it depends on the collection, but we think that about 2 grams of quaking aspen is equal to like 16,000 seeds or something like that. So huge quantities in like every collection, which is really great. And finally, this is our clipper. This is what we use for a lot of fall species, a lot of catkins, a lot of cone species. You can see here we have some graybird seeds. This is uncleaned. This is the seeds. This is the biomass. So you can also see just like how much space we're saving by cleaning this down that much. And again, we're getting a much more accurate idea on how many seeds we're collecting by calculating the weight. And here's how the clipper works. It's basically a bunch of screens that vibrate together, and it'll separate all of this like bracty material from the actual seeds we'll want. Cool. So that's how so now we've collected, we've processed, and now we're storing our seeds, and now we're ready to put them out on some sites. So these are our direct seeding experiments. Basically, we're looking for what the best ways are to plant these. Should we till an herbicide before we plant them? The answer is yes to that one. But we're looking at things like that. We have a lot of plots, and we put spring species in some, fall species in some, both in some. We have some controls, and let me show you what an actual like site looks like. Oh, actually first, let's talk about this. So these are our direct seeding locations. These in the yellow, these are ones we've done in the past. We've gone to Johnson Farm WMA in Canaan, as well as the Upper Lamoille River Access area in Wolcott. And those, of course, feed into like the Lake Memphremagog watershed, into the Lake Champlain watershed. Especially this year, we're working at the Intervale Wildlife Management Area over here in Burlington. This red dot here, and that's going to go straight into the, that's not going to go into the water quality improvement, and fish will go straight into Lake Champlain, which would be really nice. This is what our sites look like. They've been tilled and herbicided to get rid of any reed canary grass. That's kind of our big troublesome species we have to watch out for. But you can see, I mentioned earlier, these cornfield replication experiments. We're looking to make them look like cornfields. We don't want anything else growing. We want to give these seeds the best chance they have of surviving. So we do a lot of these plots. Some of them are a couple acres large. And this is kind of the why, or this is at least like kind of the spark that inspired the whole project. So after Tropical Storm Irene and Sandy back in 2011, 2012, we were noticing these huge, I mean, obviously like a huge disturbance, which was really, really terrible. We noticed fields that were kind of completely covered by sediment. I've seen these in the 2023 floods. It looks like a beach out there. So we saw these old farm fields that were totally like, basically nothing, like almost nothing living there, except for all the seeds in the soil, or the bare soil for nearby species to colonize it. So here we have this picture in 2016. Here we have this picture in 2017, 2018. And you can see even just 3 years later in 2019, we're already seeing trees that are, twice the size of a person. And this super, super dense regeneration makes it really hard to lose a lot of your trees to deer browse or anything like that. Super healthy, super natural riparian forest, great habitat. And that's exactly what we're trying to emulate, is these kind of like huge disturbance events. Why do we do it? Again, we're trying to avoid lollipop trees and rows. We're looking to avoid basically deer browse, and we're also looking to avoid the need for monitoring them long term. Sorry, not monitoring, but kind of the upkeep of them. We don't really want to have to go out and weed whack every year to make sure that these trees are surviving. We want to do kind of a high input energy in the beginning, and then we're hoping it's self-sustaining over time. We're looking to increase site biodiversity. This is, again, why do we do it, as kind of in response to versus bare root planting as kind of an alternative. Increase site biodiversity. I mean, again, last year we collected from 37 different species, a range of habitats and stuff. So we're really looking to keep that biodiversity versus just, getting 100 silver maple from a nursery and putting them all out. We're looking at this, again, dense regeneration, a more natural looking forest, and a lot of complexity too for wildlife and fish habitats. And again, we're looking at this high upfront cost here. I mean, we spend all year collecting, all year processing, all year doing all of our stats, our experiments, all for like 1-2 days of seeding a year or something like that. But again, we're hoping that it's a high upfront cost, but a low long-term cost. We're hoping that these are really like self-sustaining forests. Again, this year too, we're doing a big focus on education and outreach. Last year, we've started working with local colleges. We worked with Sterling College in the fall to collect some speckled alder. We also worked with a class from UVM to collect a bunch of silver maple. We got like 45 gallons, I think, this day of silver maple seeds, which was kind of a lot. And it was really cool to be a part of that. And it's really cool to work with all these students and get them excited about conservation. Additionally, we also worked with this NR 4060 class from UVM, where they helped us develop this really cool GIS map to show where they think that sites, like good site selection for us before we even get there. So they looked at things like A&R atlases and other like community maps to create this really awesome map that we still use today as kind of a predictor for good sites to collect from. This year especially, we've been doing a lot of workshops. We had recently our spring phenology workshop at Northwoods. We had a spring collection, silver maple collection day just last week, which was really successful. And we also had this awesome shrub willow ID led by State Sea Coordinator Brooke Fleischman with the master naturalists at UVM, or sorry, at North Branch Nature Center. And that was down at Berlin Pond. I'm sorry, Joe just started recently, so we don't have a good picture of her yet. So this is a picture of me with her in the background, so I'm sorry about that. But again, this is our first year doing an internship. This is the internship through FREC at UVM, which is Fellowship for Restoration, Ecology, and Cultures. And we're hoping to keep this moving forward in the future. Joe's been really great so far. We're also working with a couple internships from Sterling College this summer, 2 to be specific. And we're working with them at least once a week to scout and collect seeds. And we're hoping that having extra hands on deck will be really helpful for us. Intervale is also welcoming a fall intern to help with seed collection and nursery tasks. Reese and Maddie will be leaving us pretty soon in the next couple of weeks, so Brooke's going to need a little extra help in the fall. We have these newsletters that come out a couple times a year. Please read them. We put a lot of effort into them, and we think they're really cool. And they show a lot of cool like statistics and a lot of like what we're doing, the specifics. So it's a really like in-depth kind of report that's really like easy to read through and fun to read through. So highly recommend you keeping your eye out for it. To stay in the loop with all things seeds. What's next? So we're interested in developing a seed plan, and by that we mean what is our kind of top end goal? We don't want to just keep collecting forever for seeds that might not ever go out on sites. So that's what we're thinking of within the next couple of years. We're also looking to expand our infrastructure. We work up in the Northeast Kingdom a lot, which has not a lot going on up there, I'm going to be honest. So we're interested in having all of our seed processing sites are at least an hour away. So we're interested in getting sort of a seed facility going on up there, which will be really interesting. That's in the works right now. We're also looking to further develop our network. We're interested in making connections with new nurseries, conservation organizations, community outreach. We're looking at more involvement in the Northeast Seed Network, which operates a lot on the Atlantic coast. And our second kind of like moving forward thing is we're looking to continue these direct seeding trials. We really want to have like something to show for all of our work. So we're interested in getting like really nailing down all the experiments with that. We're looking to innovate our methods of collection, processing, storage, propagation, just to make sure we're doing everything as efficiently as possible and the best way we can, in the most sustainable way as possible. And finally, we're looking to actively compare direct seeding to bare root planting as an alternative. We believe that this holds like a real potential in the future, but we just kind of have to show that. Thank you all.
Thank you. Great presentation. And after having collected milkweed seeds and pulling off the little seeds, I like your idea there of the vacuum. But it sounds like you guys collect mostly tree seeds. Do you collect any other herbaceous type of seeds that might be the understory of a riparian forest?
Yeah, that's certainly something we're interested in doing in the future. We've collected a little bit of milkweed so far. We think that has a lot of potential. But with our current funding, we're doing mostly tree species. But that is definitely something we're looking into in the future.
Yeah, I was just thinking about Liz's example. So thinking of those other understories. So that's great that you guys are thinking of it. Great, thank you.
Yeah, totally.
Mine'll be quick, but I just wanted to put a plug in for Vitis riparia, riverbank grape. After the flooding along the Winooski and Richmond, you can walk those trails and see the riverbank grape holding the banks together. And I think it would be easy to seed collect, and no one's planting it.
Great. Yeah, thank you so much for that.
And other really quick question. Do you have a minimum size area that you would do a direct seeding at? Because I do projects up in the Northeast Kingdom, and I would love to have some trees there.
Sure, yeah, I'd love to get in contact about that. I don't think necessarily, but Brooke can correct me if I'm wrong. But yeah, we're just interested in getting stuff out there and seeing what it does right now. So kind of the beginning stages.
Thank you very much. Um, I lead a nonprofit organization. I can just picture walking onto some unused farmland and working with agricultural producers or private landowners. I'm usually asked for a cost analysis. I'm wondering if that's part of the research you're doing to be able to come up with information like that so we can compare it to other processes. And my second question is, have you competed with Japanese wort yet with your application method?
To the second one, I'm gonna say no, I don't think so. But to the first one, we are doing a lot of research right now on the cost of everything. We're keeping track of every species we look at, every species we collect from, every species we process, and how much time it takes us to do that, so we can get a good idea of just how much time it takes to process and collect everything, so that we're offering a good price and a good cost for our time and what we collect.
Great. It's a great service you're working on, and I think it's got real potential.
Thank you. I appreciate that.
Ken writes, are you planting and creating assemblages of plants based on historical data, maps, neighboring communities, or is it your team planning what you think is best for the area?
I'm sorry, could you repeat that?
Are you planting and creating assemblages of plants based on historical data, maps, and neighboring communities? Or is your team planting what you think is best for the area?
Yeah, so ideally it comes a lot from just what we can find and what we can get our hands on. I mean, we are using a lot of like community data. But we're also making sure that we use a lot of species that we know are riparian loving, like a lot of water loving species, a lot of species that'll do good in the floodplain and kind of hold down the banks of that. So yeah.
I can always come up with a question, but I love this so much. And I'm curious if there are nurseries beyond Vermont that you are replicating their like models off of, or other nurseries in Vermont or outside of Vermont doing the same thing that you all are doing. Just curious of that.
Like Monsanto?
Yeah, we're not working too much outside of Vermont, although we have been working with some like the Coastal Maine Botanical Garden, although they do a lot of herbaceous trees, or sorry, a lot of herbaceous plants. We have not strived that far outside Vermont. All of our experiments comes from an experiment done out in Arizona, I believe, which was kind of a first like direct seeding trial experiment that we found and that we're basing it off of. But as far as nurseries is concerned, I don't believe so. The question was, are there any other nurseries we work with in addition to the ICN? Which is true. We're working with a lot of like startup nurseries, especially the North Branch Nature Center is working on their nursery right now, as well as some in Jericho and in New York. Yep. Mm-hmm. Yeah, we are working with a number of other smaller nurseries. We're working with the Essex County Nursery over in by Island Pond. So yeah. Mm-hmm.
Yes, Martha writes, Megan, thank you for that thought. Can you share your contact information? We have never approached the La Rosa project. I'm not sure why it's in there.
Hi, so yeah, this is super exciting. And I'm glad someone online asked the question about the assemblages, because I do think that's an interesting potential. But the follow-up thing to think about as you are creating kind of your seed mix and where you're spreading it. The follow-up question is, what kind of monitoring are you doing following the seeding? And are you planning to continue to monitor the sites to see how well this works over time, and and what survives and all that kind of stuff to inform kind of the future implementation?
Yeah, totally. Yeah. So we have done a lot of monitoring. I mean, our oldest site was in Willoughby Falls, which is in Orleans, Vermont. And we've been looking at for the last decade or so, which has been really great. Unfortunately, in the last couple of years, a lot of our fields have been really negatively impacted by the flooding events. And we've lost a lot of seeds, and we've gotten a lot of them covered by sediment. So within the last couple of years, we haven't seen a ton of, we have been monitoring, we've been taking a look at them, but we haven't seen a ton of growth so far during those, but we are interested in monitoring. We just have to, find things to monitor. We have to have stuff stick around long enough for us to monitor them. So, which is what we saw in some of them, which is really great. Yep.
Thank you. Thank you so much, Jake. That was so interesting. And now I'd like to introduce Dr. Matthew Vaughn, Chief Scientist for the Lake Champlain Basin Program. And Matthew's research also focuses on land use and land cover and water quality in the Champlain Basin. So welcome, Matthew.
All right, thank you. That was a tough one to follow. I definitely want to go collect some seeds. An awesome talk so far today. Oh, here we are. Okay. So yes, I'm Matthew Vaughn. Thanks for the invitation to speak today. I'll be focusing most of my talk on Lake Champlain and its tributaries, but I think this is widely applicable, not just throughout Vermont, but also throughout the world, as you'll see. And I was thinking about how we communicate about environmental issues on my way here today, and how they can range and how visible they are to people, and how easy it is for folks to connect with them. So we have like invisible things like emerging contaminants or heavy toxic metals. And then we have things where you really see the effects like cyanobacteria blooms, but the causes are more amorphous or harder to connect with. And this is one, I think, where the contributing factors are very visible. Here's a photo of, I didn't even say what I'm talking about. I'm talking about de-icing salts. You can see a plow, we've all been stuck behind a plow truck. We see road salt go on our roads. So, and probably many of us are salting our surfaces and around our homes, communities, businesses. So the contributing factor is very visible, and we can connect with that easily, but the impacts are not as visible. So I'm going to talk about those impacts, and because we really need to study that using scientific methods. It's not something you can see like a cyanobacteria bloom very easily. Just a quick thought to start us off. But yeah, mostly what I'm talking about with de-icing salt is sodium chloride. So this is the kind of typical table salt that's next to the pepper at the dinner table. It's also the most common de-icing salt that folks use to remove snow and ice from road and sidewalk surface and parking lot surfaces. It's cheap, it's easy to use, it's very popular, and it's been growing in its use since the 1940s when it first started to be used commonly. So we're on kind of a decade-old time scale of how long we've been using this stuff. The impacts from road salt is common worldwide. This is not a unique issue to Vermont or Lake Champlain. And there's been widespread documented impacts worldwide, and especially for the Northeast US, where de-icing salt's really widely used. It adversely impact all forms of life. This has been widely documented for amphibians, zooplankton, all sorts of impacts to biodiversity, fish species as well. All parts of an ecosystem, plants as well, all parts of an ecosystem are impacted when they evolved in fresh water to have low salinity. Increase in the salinity is not good for their life cycles, as you could probably guess. There are also physical impacts to increased chloride or salinity in a water body. It can affect how easy it is for that water column to mix. I'm going to talk about that more in a minute. So there's kind of biological ecosystem impacts and physical impacts as well. I'm going to quickly go through some diagrams. Last time I gave a talk on this topic, someone asked me to add these because they thought it'd be useful. So maybe you'll find it useful too. I'm going to highlight just the most important parts of these that I wanted to share. These are from just a couple different papers that have kind of put together the overall impacts that de-icing salts can have on our waterways. So this one, I just wanted to highlight that a few studies that they put together thought that, or found that, when de-icing salt is applied to a road or driveway surface, about half of it says 40-60, but think about it, roughly half runs off quickly, and then half of it goes into the groundwater. And you'll see later how the groundwater impacts last through the summer, even when we're not seeing de-icing salt or thinking about the winter time because it's 80 degrees out. Next, it can increase salinity, can decrease macrophyte or aquatic plant biomass. It impacts their ability to grow, and it can lower the effectiveness of our natural ecosystem functions that we rely on for wetlands and lakes and ponds and all that. And then this is the mixing aspect I talked about. Saltier water is denser than fresh water. So if you have impacts due to de-icing salts in your watershed, that water can that saltier water can sink to the bottom, and it's harder to mix that. It doesn't always prevent the full mixing, but actually Mirror Lake in the Adirondacks is one of just, I think, less than 10 lakes that have been documented where the mixing regime has been documented to be impacted by stormwater or salty inputs, but it's probably likely much more widespread where you have this denser layer at the bottom that can impact the mixing regime of a lake. And that can influence other water quality concerns that kind of come along with increased thermal stratification or a stronger layer from the top to the bottom, decreased oxygen, nutrient release, all those things. To sum it up, salt is bad. That's what this one says. You have sources of salt. Road salt is the main one I'm thinking of, but also water softeners and fertilizers and dust suppressors and agricultural products. Too much salt is bad for aquatic life and drinking. That sums it up nicely. All right, so most of the results I'll show you are from the Lake Champlain long-term monitoring program. This has been going on since the even a year before the formation of the Lake Champlain Basin Program. It's done in partnership. It's funded by the EPA through the Lake Champlain Basin Program, done in partnership with SUNY Plattsburgh and Vermont DEC. And with this data, we have a paper. I'm kind of just pulling plots and results from this paper that we're just about wrapping up, looking at salinization of Lake Champlain and its watershed from the impacts of de-icing salt. So overall, this is true for the entire program, but I'm pulling out, talking about chloride specifically. Again, that's a component of road salt. There's sodium, there's chloride. Chloride's what I'm talking about. So when the road salt hits the water, it dissolves into those two parts. We have data going back to 1991. We have 18 tributaries we're looking at where the data goes back far enough to look at these long-term trends. Over 8,000 samples for these tributaries, 15 lake sites with over 7,000 samples. I'm looking at just the top layer, the Epilimnion part of Lake Champlain. And here's a map of, so it's all over the watershed. And for the tributaries, we're looking at just the mouths of the watershed. That's where this monitoring program takes place. So just before it enters the lake, trying to capture what's entering Lake Champlain. And then the 15 lake sites are distributed throughout the lake. I'm going to quickly go over how I determined what's going downstream in these tributaries. So we're going out with a long-term monitoring program about a dozen times per year in these tributaries, and but we're measuring stream flow or river flow every 15 minutes through the U.S. Geological Survey. So I use some fancy modeling tools to predict the daily concentration and load, or the amount of chloride going downstream, all the way back to 1990, and then you can wrap that up into annual or kind of annual loading to Lake Champlain and look at trends over time. If you want to know more, just ask a question. We can geek out on that. So just to be clear about terminology, when I say concentration, that's the amount of something in a unit volume of water. Okay, and that's kind of what matters if you're a frog or a fish. That's what you care about in your cubic meter of water, how much chloride or what any other contaminants are impacting your life. That's concentration. So we're talking about milligrams of chloride per liter in this case. And the overall trends are chloride is increasing in nearly all of our tributaries to Lake Champlain. That increase is statistically significant in 15 out of 18 of them, but there's apparent increases in all of them over the past 3 decades or so. The magnitude of increase ranges from 41 to 163%, so more than a doubling in that annual average concentration for our tributaries. And that magnitude, well, we'll get into the numbers soon, but overall, it's going up. That's, if you leave with one thing, it's getting saltier. Okay. I'm going to pull out results for the Winooski River, our largest tributary to Lake Champlain. And I'm going to do this throughout where I'm going to go over what's on this graph before I show you what the graph is. Hopefully this is helpful, and just tell me to stop if you don't like it. But in the vertical axis here, we have milligrams chloride per liter. Again, the annual mean concentration or annual average concentration for chloride. Looking at 20 to 30 milligrams per liter in this case. And then the horizontal axis is time, so going all the way back to about 1990. And here's what that looks like over time. So we're looking at, sorry, it's hard to see the axes on the screen, but we were at about 10 milligrams per liter at the beginning of this program as an annual average, and then we are approaching 35 milligrams per liter now. And those numbers might not mean much to you, so I put some ways to think about this and some kind of benchmarks to kind of bound your understanding of what different concentrations might mean. So if generally, if we're above 10 milligrams per liter in a lake, that would be considered greater than the natural background concentration. So there's some impacts due to probably road salt in the watershed. That number is a bit higher in rivers. If you're greater than 20, that's kind of the highest you might see in a natural setting. 35 milligrams per liter is where there are clear documented impacts to biodiversity. So that's where we have a real impact that we've observed. Then EPA has some thresholds for us to consider. 230 milligrams per liter is the chronic threshold, meaning it should not be exceeded for greater than a 4-day period. And then the 250 milligrams per liter is a secondary drinking water standard, so that's where taste starts to be impacted. So it's secondary, meaning it's not public health necessarily, but it is not something that we want for our drinking water. And then 860 milligrams per liter, that's the EPA's acute threshold for toxicity, so for aquatic life toxicity. So you don't want to exceed that for more than 1 hour over a 3-year period. So much stricter for that one. And these EPA thresholds are really for fish. They don't really they weren't designed to consider critters that might be more sensitive, like our zooplankton or our macroinvertebrates, things that are critters in our rivers, lakes and rivers. It's really about fish, so that's something to keep in mind as well. All right, and so that, that's the Winooski River, again, our largest tributary, over 1,000 square miles watershed. And that's kind of an integrated signal. So that has mountainous forested areas, it has developed areas, it has our biggest cities. But if you go to pockets of that watershed and throughout the lake's watershed, you have areas where there's very little or less impact, and then much greater impacts as well. So Sunnyside Brook is an example where we have a greater impact. This is where the Vermont DEC developed their first TMDL for chloride specifically. So again, I'm going to show you, before I put the data up, the vertical axis, we're looking at much higher concentrations. So instead of 10, 20, 30, we're looking at 200, 600, 1,000 milligrams of chloride per liter. And the time frame is very different too. We're looking at just about a year rather than 30 years. So back to December 1st, 2019. Again, this is monitoring of Sunnyside Brook near Costco in Colchester. This eventually drains the Winooski River, but it's a small watershed. It's about 0.6 square miles compared, again, to over 1,000 square miles for the Winooski River. So what we have here, and I'm going to put labels up here. This is adapted from the TMDL. I just added some things to it. The line here is that chronic threshold I talked about, and the higher one is the acute threshold. So you're seeing that almost that entire year, Sunnyside Brook was above the chronic threshold for chloride concentration, and at times it was also above that acute threshold. So that's why they implemented this TMDL. Here's a table just kind of summarizing that. The chronic exceedances, percent of the time, 100% of the time exceeding that chronic threshold, and then exceeding that acute threshold, fewer percentages. And I put this up here. I don't usually put tables in presentations, but I think it's interesting to show that the times when you might expect chloride concentration to be highest in the winter is actually lower. And that's because unlike some other pollutants that increase with greater stream flow, chloride's the opposite. It usually dilutes. And that's going back to that one of the first slides I showed, where half of it tends to run off right away and half of it goes into the groundwater, roughly. In the summertime, when most of the stream flow is that groundwater, low flow condition, that's when concentrations are usually highest and the impacts to our biota are also greatest. So even though it's being applied in the winter, our biota, our critters are feeling the impacts in the summer. So again, getting back to that, we're seeing it in one place, but we're not always seeing the, we're seeing it applied, but we're not seeing the effects. It's not as easy to see or connect to. We're not thinking about it in the summer. All right, so we talked about concentration. Now the load, meaning the mass of chloride delivered to a water body over a period of time. So in this case, we're talking about metric tons of chloride per year. So you probably have heard about phosphorus TMDL, where we're thinking about metric tons of phosphorus per year, similar, but now we're just talking about chloride here. Similar story. The trends over the past 30 years, 15 out of 18 of our tributaries had significantly increasing chloride loads over this time period, and the magnitude ranged from a 2% to 127% increase. For the greater increases, we're talking about tens of thousands of metric tons more per year than was delivered about 30 years ago. To demonstrate that, again, Winooski River, highlighting this, our largest tributary, we're looking at tens of thousands of metric tons of chloride. It's a lot of salt, right? Tens of thousands of a metric ton is, if you picture an African black rhino, that's 1 metric ton, a large animal. We're looking at thousands, tens of thousands of metric tons of chloride every year, okay? And here's what the plot looks like. So in the early 1990s, we saw about 20,000 metric tons of chloride every year going into the lake, and now it's about double that. So that was 44 million pounds of chloride, and now we're up to about 88, 90 million pounds of chloride in another unit. Again, a doubling of the amount of chloride going to the lake every year. Let's sink in for a second. Hard to see. We cannot see this with the naked eye. It's not a cyanobacteria bloom, but we see it being applied to our surfaces, and we have a bucket maybe in our garage. I took out I know I'm right before lunch, so I took out some of these slides, but I just wanted to say that I was able to do a statistical analysis to look at whether the changes in stream flow, more or less water moving downstream, might be impacting that loading over time while we have a doubling in the Winooski River. And the results are very clear that the changes were not largely attributable to changes in stream flow. It really was because of the changes on the landscape and the higher concentrations over time. So that was all tributaries. So now looking at what's going on in the lake as a result of what's happening, we just looked at in the watershed. Vertical axis here, again, we're back to milligrams of chloride per liter. We're looking at 0 to 15, roughly. Sorry, there's a lot of pollen out there. Allergies are rough today. And horizontal axis, again, going back to 1990. And here's what that looks like. You can see, if you remember what that looked like in our Winooski, this pattern of kind of increasing and a bit of a decrease and then an increase in the past decade. It's really mirrored in the lake, which is not that surprising. Chloride, it tends to move. It doesn't want to stick around. And it doesn't interact with many things. So something like phosphorus or nitrogen, it can transform, it can absorb to sediments, it can be released over time, and it can kind of cycle through the ecosystem as it moves downstream. Chloride is much less interactive. Once it's released, it kind of moves through the system. So it's very different in that way. And that's also why we're seeing a close mirroring in the lake from what we see in the watershed. The increase in chloride levels, depending on the region of Lake Champlain, range from about 20 to 54%. So pretty meaningful increases. Just wanted to mention some of the ongoing research we have in this area. That everything I showed was from an article that we're wrapping up and hopefully will be published soon. We have ongoing work in Mirror Lake that I mentioned with Adirondack Watershed Institute. We have basin-wide studies of chloride data beyond what I showed, so more up in the watershed. We'll be collecting whatever is available out there. We're also looking at downscaling climate models to consider how climate change will impact our reliance on road salts. Unfortunately, you might think that with rising temperatures, we'd be using less road salt because there'd be less snow and ice. But actually, what it means is that we're more frequently crossing that freeze thaw barrier, and it's harder to manage for road safety. And road crews tend to use more de-icing salt, and that might be part of why we're seeing increases in the past decade. And then we also have a study in collaboration with Middlebury College looking at different chloride sources in different types of watersheds and their impacts on macroinvertebrates. And they have some lab experiments going on with that. I appreciated, I didn't include it here, but Stacy had some kind of what we can do about it slide. So I'll just add a few thoughts on that. And Lake Champlain Sea Grant has the best resources on this, where they have videos on how to reduce de-icing salt use on your own property. And when you're thinking about de-icing your sidewalk or driveway, the first thing we work on is to increase the physical removal of snow and ice before road salt is applied. So we have grants with folks who are replacing plows. Instead of a straight edge plow, there's something called a live edge plow that can conform to the road surface, so it gets more of the snow and ice off the road surface. And then the other big one we work on is brine making an application. So it's just a salty water mixture, and that uses about 40% of the amount of salt, and it's more effective because it sticks right to the road surface and does its job, whereas rock salt can bounce away and not dissolve, and it doesn't do the doesn't have the effect that we want it to. It's not as effective for the mass that we're applying. And then Sea Grant has other great tips, like the temperature really matters. So if you're less than 16 degrees Fahrenheit and you apply sodium chloride, it's not going to do anything, because sodium chloride only breaks that bond and lowers the freezing point of water above 16 degrees Fahrenheit. So having that knowledge is really helpful for people, I think, to reduce their use. And then also thinking carefully about where you're applying road salt. Do you really need to melt your entire driveway, or maybe just a walking path from point A to point B? Again, helping people connect with what they're seeing in the wintertime, and then what's harder to see, but we can communicate on the impacts to our ecosystem. And I didn't get the memo about putting a photo of myself up there. I think, was that supposed to be part of it? I'm sorry. Okay. That's it. Thank you. Liz, 10.
Thank you, Matt. This is really informing. Going back to one of your earlier slides where you were showing that the chloride tends to settle and the direct relationship to the bottom of the lake bed. I'm thinking about the shallow bays in Lake Champlain, but it exists all over the state, these shallow bays where we have a problem with legacy phosphorus that is releasing, even though we're doing a decent job of stopping the nutrient flow into a water body, we have that sitting there, and we have challenges of climate change. I'm wondering how much effect this increased chloride has, and if there is research being done on that quantify that, so there's some more information.
Yes, it's a greet question.
Can you repeat the question, please?
Yes, the question
Thank
is
you.
about the slide. Is the voice coming from the other? But yeah, thanks for asking for that. So I'll try to rephrase Ken's question. It was about the slide I showed where increased chloride or salinity can influence the density of water and impact the mixing ability, capacity, or increased thermal stratification, or stratification. In that case, it's not thermal because it'd be due to salinity. But kind of strengthen that stratification. And then Ken's asking about the release of phosphorus due to lower oxygen levels, how much of this is a factor. So the answer is it is a contributing factor to the dynamics of the physical dynamics of any lake. Okay, so you lakes and even bays or areas within lakes will have physiographic aspects that will make them more or less likely to mix with a certain amount of energy from wind or from temperature changes seasonally. And when you have another factor influencing the density of water, it can require more energy to do that mixing. So, Missisquoi Bay or Lake Carmi, for example, have a certain amount of stability over the season. If you have especially if you have a salty input in one area and not another, for the salinity, the important piece is the differences in density or differences in salinity. If it's all the same, then it's not going to be impacting that density as much because it has to be kind of fresher in one area and denser in another, and one kind of sinking under the other. So I don't have a great specific answer for you other than that it can be a factor, especially in like urbanized areas, drinking water reservoirs, bigger cities. You see this much more frequently where the salinity is really impacting things, and they might have to go in with an engineering solution and physically mix things. In natural water bodies, I mentioned Mirror Lake. They had a very small and relatively high urbanized watershed, and the stormwater was really impacting the stability of that lake. If you look at Missisquoi Bay, for example, it's very polymictic, meaning that a wind event is likely to mix it. And that stratification is happening over, a few days to a week of calm weather. Increase in salinity is not likely to have a large impact on that bay. But on another lake, depending on the situation, it certainly could be a factor. I'm kind of talking around the answer, but that's how I think of it, is it's another factor that can influence that process. Yeah, exactly. Keep it in mind, yeah.
So chloride seems to be a bigger issue in our end of the state and its impact on the lake. I'm wondering if you could answer two questions. Number one, what would you consider to be the best source now for demonstrating to the powers that be that this is something we need to pay attention to? And two, is the science going to mature in the near-term future? And if so, are we talking 1 year, 2 years, or 5 years, or 10 years?
Okay. The first question is, what do I think is the best way to communicate this to folks who have powers to make decisions? Our role at the Lake Champlain Basin Program is to monitor, do the research, and provide information. I hope that I've kind of taken this on the road. I'm on tour with this talk. We've added it to the Lake Champlain Basin Program State of the Lake report, and this is the second time it was in there. So it's been kind of 6 years where it's hopefully more of an issue that people are becoming familiar with. I've been interviewed on it on TV, news programs, and on the radio. So again, I'm kind of doing my thing. I know that lawmakers are taking notice, and there was a bill that moved through the Senate. I think it started in the Senate and made its way to the House. I am not very good at the policy and legislation side of things, but I did testify in both committees. So I know that that was the kind of energy and environment committees in each chamber. So I know that they're taking notice and taking it seriously. I'm not sure the current status of that one. And then you asked about science advancing. I'm not sure what you meant in terms of monitoring or in terms of what its effect on the lake might be. Yeah, great question. So we have a pretty good understanding on the effects of chloride and salinity on our ecosystems. I forgot to kind of summarize what it means for Lake Champlain. It's fairly well mixed throughout the lake, and fairly well mixed between the top portions and the bottom portions. The South Lake, there is differences between the different layers of the lake. But we're not at the point, you go back to think about the thresholds where kind of 35 milligrams per liter is where we have impacts to our critter or biodiversity, and up to 230 is the chronic threshold. We're 10 times less than that right now at Lake Champlain. We're not close to the impacts to drinking water. For the lake, it is a signal that we're concerned about, that we're nearly doubling what was likely the background concentration. We started measuring in 1990, so it was probably impacted at that point because road salts were first used widely in the 40s and have kind of increased since then. But I think the greater impacts right now are in our tributaries and headwater systems, thinking about today's focus. A place like Sunnyside Brook or other where a quarter of its watershed is impervious, small watershed, but a lot of impervious areas that's presumed to be treated with de-icing salts, that's where the greatest impacts are for our biota there. Yeah.
Cheryl Barkley from Lake Elmore Association asks, are there safe alternatives to road salt, safe for cars, people, and the water, or is brine the answer? And does brine work on dirt roads? Also, if alternatives are used, does the damage dissipate over time? And do lakeshore plantings help relieve the amount of chloride delivered into the water body?
Wow, there's a lot of great questions in there. Okay, I'll try to take them one by one. Alternatives. There's a lot of discussion on alternatives. A lot of people have looked at them in like pilot programs. What we haven't invested too much in those alternatives to your traditional sodium chloride because our state, the VTrans, has let us know that they're unlikely to adopt them because of all the uncertainties with, I mean, think about one example is beet juice. That's kind of a popular one because there apparently is a lot of leftover beet juice that people could use, and it would lower the freezing point of water. But then you're applying organic material, and it'd be difficult to deal with and transport. And we've heard from VTrans that they're just unlikely to go that route. They, again, sodium chloride is low cost, it's effective, and so we have really focused on the physical removal first, the appropriate place and time and rate of application, and brine when we can do it, because brine is so much more effective and will reduce the amount of the mass of sodium chloride you need to use. What were the other ones? Give me one more. Sorry. The lag in the system. Right. Yep. I don't have a good sense of that, although, sorry, I'll repeat Liz's question, which I think maybe was the same one. So what is the lag in the system? We're applying salt this winter. When do we see it, essentially? And that we know that that our soils and our groundwater are elevated in sodium and chloride. We have a lot of data from the Adirondack Park where people's wells are high in sodium and chloride, and the groundwater is slower moving. It's moving over decades rather than months or years. So there is a pool out there of chloride. However, it does tend to move through the system. Like I said, it doesn't stick around and doesn't transform into other things like phosphorus or nitrogen might. So chloride that's applied in a given year, again, half of it will move quickly, and then half of it might kind of trickle out over the course of decades. But I do think addressing this issue, unlike kind of legacy phosphorus issues, I do think that turning the spigot off or down now will have a greater impact because chloride does tend to move through systems more readily.
Does the brine work at different temperatures or a broader temperature range than does rock salt? And in addition to that, also is the brine program being done on a contractual basis or being rolled out statewide or town by town?
Yeah, thanks. Okay. I'm not 100% sure, but I think that the 16-degree Fahrenheit limit, it has to do with the chemistry of how sodium chloride dissolves. So that would be the same, I think. I'm not really a chemist. I think it would be the same for brine and rock salt, but the advantage of brine is that it sticks more immediately to the road surface and melts on contact. Road salt will bounce around and melt kind of in little circles. You've all probably seen if you drop salt on a snowy surface, you'll have like the circles that will melt, but not the full surface, and brine will be more effective again and use less mass. And then what was the next one? There was a temperature, and then there was, is it being rolled out? It's essentially, I think, being rolled out on kind of crew by crew and Department of Public Works by department. We've had a lot of adoption on the New York side of the Lake Champlain Basin. There's been some adoption in Vermont, but not quite as much, I think. And Lake Champlain Sea Grant is again leading this outreach to.
Kelly has one, but we have two more here. Yeah. Is Epsom salt used on veggie gardens bad? And how does the cost of brine compare to the rock salt? And does brine work on dirt roads?
Okay, I will defer to another gardening expert on the Epsom salt question, but what's the cost of brine versus road salt? Was that it? Of rock salt? Okay. So the capital invest for a road crew to start using brine, the capital investment can be a burden or a obstacle because you have to have a machine that brings a proper amount of rock salt and water together, mix it properly, store it, versus having a big shed where you have a pile of salt. So a lot of places, towns and cities will have the salt shed, but brine has to be indoors. It has to be, there's an investment there. But then once it's up and running, you're buying less salt for the same impact or same level of service on your roads. Okay, Kelly.
I just want to add really quickly that if you're looking for total chloride data on your lake, inland lakes, we have that. We've been taking that for about 20 years during the spring turnover at the surface and the bottom, looking specifically to see if any of our lakes were permanently stratifying. We also have it in the next generation summer lake assessments, top and bottom, so you can look for that information on your lakes. And I believe that Mark Mitchell in our lake monitoring program, when he does his QC visits on your lake, he will be taking total chloride on the surface and the bottom as well. So you can start tracking that, and I urge you to look at that data and see what's happening on your lakes, inland lakes, because we can do something, especially on those smaller watersheds.
Thank you, Kelly. All right. Good. Thank you.
Okay, we are at our lunch break. We're going to take 1 hour, so we'll be back here at 1:35, and we'll see you then. Thank you, everybody.
To make sure folks can see my presentation.
Hey, hi, everybody. Welcome back from lunch. So our next speaker is Tyler Brown, and Tyler is going to speak to us. He's online, so he's speaking to us over Zoom. Tyler Brown is a wildlife biologist for the Vermont Fish and Wildlife Department, and his responsibility is for the beaver baffle program in Fish and Wildlife, and he also works with the fur bearer program. So Tyler, hopefully you could hear me and you are ready to go.
All right, can everybody hear me? Can folks hear me?
We can hear you.
Okay, all right, perfect. I'm gonna just try. All right, and everybody can see the presentation?
Looks fine. We can hear,
Okay.
we can see it.
All right, awesome. Yeah, thanks everybody. My name's Tyler Brown. I'm a wildlife biologist with Vermont Fish and Wildlife. And one of my job responsibilities with the department is overseeing the Beaver Wetlands Conservation Project, or what we often refer to as the Beaver Baffle Project. So for the next few minutes, several minutes, I'm going to be talking about beavers and kind of their role that they play in watersheds and how they can kind of alter and impact the landscape, and how they have a lot of benefits for people, as well as, of course, fish and wildlife species. Beavers are really adapted and evolved for life in and around the water. on land, they're kind of this humped back, clumsy animal, and they really don't venture all that far from land for the most part. They'll usually stick to within 100 yards of the edge of the water. In the water, they're torpedo shaped. They have large hind webbed feet that allow them for efficient swimming. They have a flattened tail that is pretty much full of fat, and that acts as like a rudder when they're swimming, and also almost like a kickstand when they're walking on their hind legs carrying mud and debris on land. They have a transparent membrane that closes over their eye when they're swimming underwater, almost acts as like a swim goggle so they can see, and it helps protect their eyes from any vegetation or sticks when they're swimming. Their nose and ear channels automatically close when they dive underwater, so they're not ingesting any water when they're swimming. And they have fur-lined lips, which I think is pretty interesting. And those lips close behind their incisor, their front incisors, so they can carry sticks. They have a really good ability for converting each breath that they take into usable oxygen. So humans, when we take a breath, we can convert about 15% of that breath into usable oxygen, whereas beavers can convert as much as 75%. Beavers are herbivores, so they don't eat fish, but they eat plants. So they're eating primarily the cambium layer of trees, and that's going to be that inner layer of the bark that supplies the tree with most of its nutrients. Some of the common species that they are going after are going to be your aspen or poplar, willows, alders, maple, birch trees, a lot of the species that are growing in and around wetland habitat. For the most part, they avoid your conifers like your white pine, spruce, hemlock, your fir trees, but they will occasionally cut those down to build dams. In the summertime, they're going to be eating, or they will eat aquatic vegetation, grasses and sedges, lily pads and tubers and things like that. So this video just demonstrates how sharp those front incisor teeth are. That was about a 8 to 10 inch red maple, and when I first put the camera up at that site, it was that beaver was just starting to chew on that tree, and I think it had that tree knocked over in about a week. Which again, it was in a really good spot, so it had other places that it could get food, but it again just demonstrates how sharp those front incisor teeth are. Beavers, they live in a colony, and that colony is going to be typically made up of 2 breeding adults and then multiple generations of kits. So those adults will that female will give birth to 2 to 6 kits on average in the springtime, and those kits will stay with that parent colony for about 2 years. So then that following spring, that female will give birth to another 2 to 6 kits. And then that next year after that is when the kits that were born that first year get kicked out of that colony and are forced to find their own place to live. Beavers will live in lodges or bank dens. So you've probably all seen a beaver lodge, or where they've burrowed into the bank. They have multiple entrances that go underwater entrances that go into those lodges. And in the wintertime, or in the fall time rather, they're working on building an underwater food cache. And that's what they really survive on through the wintertime. So when a lake or pond freezes over, those beavers won't be able to get out on dry land other than inside their lodge. And they're going to be feeding on that food cache for as long as the pond's frozen over. So usually in the fall time, they're really busy with cutting down trees, and that's when you notice a lot of tree cutting activity by beavers. But the lodge itself, it has multiple chambers or levels. So that lower level is where those beavers will bring in those sticks and feed. And then the upper level is actually almost like a sleeping chamber, if you will. And they'll build almost like a little nest, and that's where they'll raise their young. So there are multiple levels to the beaver lodge. And a beaver's territory, it depends on the quality of the habitat. About a half a square mile would be on the large size of a beaver territory here in Vermont. So beavers are territorial animals, and they will defend those territories against beavers from outside of their colony. But like most wildlife, they try to avoid direct conflict with one another because there's a lot of risk in doing so. So one way beavers can do that is by marking their territory with castor mounds. So what you just saw in that video was a beaver making a castor mound, and all it is a pile of mud set on the shore or the edge of the water. And beavers have a scent gland called castoreum, and they'll secrete some of that on that pile of mud. And what that does is it lets any other beavers that are swimming through that area know that, hey, this area is occupied. You should move on and look for another place to live. Beavers also have oil sacs, and they will use that oil secretion to clean and waterproof their fur. So that beaver in the background was doing just that. It was secreting some of that oil and working it into its fur to help keep it waterproof. You've probably heard the term keystone or keystone species. So beavers are known as a keystone species. So beavers, why they're a keystone species is because they can create habitat that other wildlife utilizes in some portion or all of their life cycle. So beaver dams are really the basis or the start of the food web. When a beaver builds a dam across a stream or a river, what that does is it's slowing the flow of water and kind of pretty much increasing the productivity of that water. So it's increasing the abundance of plankton, phytoplankton, your zooplankton, your macroinvertebrates, and aquatic insects. And then your fish are going to be feeding on those aquatic invertebrates. Your birds, like your heron, your kingfisher, will be feeding on those fish. And then also you're going to have your mink and your otter that are going to be feeding on those fish as well. And these areas are really good places for your reptiles and amphibians as well. And then not to mention your countless number of songbirds and waterfowl that are going to be using these areas as well. So these wetlands that beavers create are really our aquatic filters for these habitat. And when beavers build their dam, they're again helping slow that flow of water. And what they're doing, or what they can do over time, and when they're allowed to do it in the right locations, they're helping reconnect that stream with its floodplain. So when we get a heavy rain event, rather than all of that water just building momentum flowing downstream, it's allowed to disperse out into the floodplain, which can help reduce downstream flooding and erosion. When we're talking about lakes and ponds and how beavers can benefit lakes and ponds, you may ask, like, how can a beaver be that beneficial for an established water body? And really, when we're talking about that, the benefits are coming from those tributaries that are flowing into a lake or a pond. So again, when beavers build that dam across that tributary that empties into a lake, they're helping capture a lot of extra water and a lot of extra sediment that may otherwise just flow downstream and end up into the lake. So that's going to include your sediment and any pollutants that may be in the water as well. And beaver dams, important to know, beaver dams aren't any long-term barrier to fish passage. There's been plenty of studies that show fish can actually navigate their way through beaver dams or around beaver dams during high water. So there's no long-term impact to fish. And in fact, some of the best brook trout fishing that I've ever found is in and around beaver-created wetlands or beaver dams that are on streams. When we're thinking about the benefits of beaver-created wetland habitat, we're often thinking about the benefits of when beavers are active in those locations and have an area flooded. But beaver-created wetlands are cyclic in nature. So what I mean by that is beavers will move into an area, build a dam, usually build a series of dams, flood that area, and they'll live there until they deplete the food source. And once they deplete that food source, they're going to abandon that site to go to some other location where there is a better food source for them. And once they abandon that site, they're no longer maintaining the dams, and those wetlands will dewater over time because those dams become quite porous when beavers are not actively repairing them. And all of that sediment that was trapped under the water is incredibly rich with nutrients. So when it's exposed to the air, all those seeds that are left there, it greens up pretty quick, and it can look something like the photo on the left-hand side. And this creates a lot of good habitat for wildlife as well. So in the springtime, these wetlands and abandoned flowages, either active or abandoned, are often one of the first locations that black bears will go to, because it's one of the first places that has green vegetation after they're coming out of hibernation. Then later on in the year and later on in that cycle, when things grow up and get a little more thick, we'll have our deer that will go there to raise their fawns, because it's a good places to hide those fawns in the springtime and through the summer. And then because of that, we're going to have our predators like our bobcats and coyotes and foxes that are going to be hunting around these locations, because you'll have a lot of prey species for them. So talking just very quickly or briefly about history, much of our infrastructure here in Vermont, which is including our railroads and our roads and culverts and things like that, were built in the absence of beavers. So beavers were extirpated due to unregulated take and habitat loss by the early 1800s. And then we reintroduced beavers in the 1920s and 30s into the state. But between that time when beavers weren't on the landscape, that's when we built a lot of our infrastructure. And during that time, since beavers weren't here, we didn't really have an idea or a picture of what things could look like with beavers on the landscape and some of the conflicts that may happen around our infrastructure. So again, beavers have a really important role on the landscape for the habitat that they create. But in certain situations and at certain sites, they can create issues for us. And a lot of it revolves around our infrastructure. So our roads, our culverts, homes, and things like that. And as the beaver population continued to grow after those reintroductions, conflicts kind of continued to rise. And what we've found is that people really value wildlife until it begins to create issues for them and cost them money. And we really want people to value beavers and wildlife because there's a lot of importance with that. So in 2000, we created the Beaver Wetlands Conservation Project, or what we often call the Beaver Baffle Project. And this was a project developed to provide technical assistance to towns, landowners, road crews, anybody who's having issues with beavers. And the goal being to, when possible, maintain beaver-created wetland habitat, for the benefits of fish and wildlife species, but also for the value and benefit for people as well. So then in 2002, we developed alongside DEC the best management practices for resolving human beaver conflicts in Vermont. So this document really discusses beaver biology, management, and techniques for resolving conflicts, and then discusses some of the rules and regulations surrounding wetlands. So we kind of get all sorts of different calls regarding conflicts with beavers. So it can range from anything from beavers chewing trees to plugging culverts, flooding septic systems, living in somebody's backyard pond. The range can vary quite a bit, but some of the most common calls are related to public and private infrastructure. And part of my responsibility with this project is I cover the whole state of Vermont, and I can do site visits to provide folks with site-specific recommendations to resolve their conflict with the beavers that they're having. So from the time period of 2018 to 2023, again, infrastructure, public and private infrastructure made up over 70% of the conflicts that we received and did site visits for. So on average, throughout a calendar year, we are receiving 400 calls or emails regarding beaver activity. A lot of those calls are things I can just answer over the phone, so they don't require a site visit. Again, one of the most common calls I receive is beavers living in somebody's backyard pond. And since the funding for,
people on this
since the
webinar or
funding for our project comes from the U.S. Fish and Wildlife Service and a grant from the Vermont Duck Stamp Fund, we're really focused in on beaver-created wetland habitat. So in those situations where beavers are in somebody's pond, they're not really influencing wetland habitat. So I can either answer their concerns over the phone, or I can refer them to a private contractor that may be able to help them resolve the conflict that they're having. So from those 400 calls and emails, I'm doing around 50 site visits throughout the state. And again, most of them, or 70% of them, are involving public and private infrastructure. And then about a third of the sites that I look at, the recommendations I am making are to install a water control device, which would be a beaver baffle or exclusion fence, which I'll touch on here in just a second. But about a quarter of my recommendations are to just monitor the situation. So that's kind of a catch-all category, and that can mean maybe the beavers really aren't creating a conflict at this point, but we just need to keep an eye on it, because if their activity shifts a little bit, maybe then there'll be a conflict that we can address. So on a couple of the devices that we can install in certain locations to resolve conflicts. The first one would be exclusion fences. So this is going to be a device that's installed at the inlet of a culvert. And the idea is that this fence will or can prevent beavers from getting access to the culvert and plugging it. Beavers really like to plug culverts, and one of the reasons is because they're attracted to the sound of running water. So the sound of running water is a trigger for beavers to start to build dams, and a culvert, oftentimes when water's flowing through it, it's just echoing that sound. So it's kind of just calling beavers to come to that site. And also, the way the beavers see it is that the road is the dam and the culvert's just a hole in the dam that they need to plug. So rather than build a 100-foot dam, all they have to do is plug a 3-foot culvert. So they're working smarter rather than harder in those situations. So I've found in my experience that these exclusion fences work best when the primary beaver activity is upstream from the culvert. So you can see in the photo to the left, there's a beaver dam 30 to 40 yards upstream from that culvert, and that's where the beavers have their lodge, and they're spending majority of their time. And they were just coming down to this culvert to plug it, raise the water level up so they could get some access to the trees on the side of the bank. So that's kind of ideal, is when the primary beaver activity is upstream from these culverts. Couple more examples of exclusion fences. So I will often install a beaver baffle, which I'll explain here in just a second, through the exclusion fence. And the idea with that is that if the beavers begin to dam around the fence, that pipe system, the baffle, will limit how high the beavers can dam on that fence. And it's just kind of a safeguard, because ideally the beavers won't dam around it, but they occasionally do. So it kind of just adds a little insurance policy for those situations. The other device we have are beaver baffles. So this is going to be a device that's installed through a beaver dam to help control the water level in that pond. So if a beaver has built a dam and it's flooding somebody's property, and those people want the beavers there, but just can't have the water flooding their lawn or flooding their timber or something like that, we may be able to, in certain sites, install a beaver baffle to help control that water level, drop it down a little bit to where it's not creating that issue that it was, but allow the beavers to remain on site and have some kind of wetland. So it's a pretty simple device. So I'm usually using 8-inch, 10-inch, or maybe 12-inch pipe, and connecting that pipe all together to the inlet of the cage. And that cage gets floated out anywhere between 30, 40, 50, even 60 feet away from the dam. Kind of the further distance, the better. If that cage is dropped too close to the dam, the beavers will just figure it out, and they'll just think it's a hole in the dam that they need to plug. So you really want that cage to be pretty far away, within reason, from the dam. And the way it works is that cage will be dropped over the edge of the boat. It'll sink to the bottom. Water will enter that pipe, and then flow through that pipe to the dam, to a notch that we carve through that dam, and then down below. So when it's all installed, you really don't see much of it, only really where the pipe comes through the dam and down below. I always get a kick out of this video. This is a beaver baffle that I installed several years ago, and the sticks that are crisscrossed over the dam or across the pipe are what I put in place. And the beavers have already repaired the dam over the pipe. And what they're doing now is they hear the water running through the backside of the pipe, and they're trying to bring sticks and mud over there to stop that. Because normally they're just going to be working at the top or the front side of the dam and not worrying about what's down below. But that sound of running water is kind of driving them crazy, and they're trying to stop that flow of water. So when a beaver baffle is working correctly or properly, it'll create kind of it'll maintain a lower water level. So depending on the water volume that is flowing through that site, it may take a couple of days or maybe even a few days for it to drop that water level, but it'll create kind of a headspace on the dam. And landowners really need to have some tolerance for fluctuations in water level, because after a heavy rain event, or in the springtime when we're often getting more rain showers, that impoundment may remain full for a longer period of time, because it's unlikely that the baffle is going to be able to maintain that water level year round. So when it rains, we get a heavy rainstorm, rivers rise, and then it'll drop back down after a few days. But for both beaver baffles and exclusion fences, water volume, water depth, site layout, and beaver activity are all factors in determining how successful these devices are. Water volume probably being the number one factor. So in areas where we just have a lot of water flowing through a site, it can be difficult to get a beaver baffle using 8-inch or even a couple of 12-inch pipes to be able to move that much water to maintain it at a lower height. And then, like with most things, These devices do require maintenance. With beaver baffles, I often recommend once a year lifting that cage up off the bottom of the underwater just to shake out any mud that may accumulate in the cage. With exclusion fences, I usually recommend clearing off any debris or leaves that may float up against the paneling, again, once or twice a year. With a little bit of maintenance, these devices can last a really long time. We have had a number of devices that we installed toward the beginning of this project in the early 2000s that I actually just replaced within the last 5 years. And I replaced them because the wood started to rot on the fence. So again, in the right locations, these can work really well. So since the project's inception in 2000, we've installed over 350 devices, which have influenced 3,800 acres of wetland habitat, beaver-created wetland habitat. We have around 100 devices that continue to function each year, which continues to influence around 1,200 acres of wetland habitat. So you may look at that and be like, you've installed 350 devices, but only 100 are functioning. That's not very good success rate. And while some of these devices do fail, it's more often related to beaver activity. So when we install a beaver baffle through a beaver dam, we'll leave that in place until the beavers abandon that site. Because again, beaver activity changes over time. So it's expected that beavers will abandon that site at some point once they deplete that food source. And when they do, and the pond dewaters, we'll actually go in and salvage that material so we can use it elsewhere. And then we'll mark that down as removed. But again, we have around 100 devices that continue to function each year. In each year, on average, we're installing around
2-minute warning about.
Perfect.
Okay.
And each year we install around 10 to 15 devices again throughout the state. And that's actually all I had. So it was good timing.
So sorry for interrupting.
No, you're fine. So yeah, this is my contact information. Anybody can feel free to reach out. And we have a bunch of information on our website at that link there, vtfishandwildlife.com/beavers.
Great. Thank you, Tyler. I think are there some questions?
One from the chat. Tyler, when you say private contractor, do you mean a trapper?
No, so the private contractor would be Beaver Deceivers. So they do very similar work to myself. So he's available to hire to install different water control devices or flow devices. So in those situations that I was mentioning earlier, where it's like a backyard pond where there really isn't beaver created wetland habitat, if the landowner wants the beavers there, or doesn't mind the beaver being in the pond, but can't have it raising the water level of their pond. It's not a site that we're going to work at, but they could hire Beaver Deceivers or another private contractor to possibly install some kind of device to solve that site or solve that problem rather.
Yes, good afternoon. That was great. I've got two questions. You said that once the food is depleted, the beavers will leave. First question is, how long does that take? And I assume that that depends on a lot of factors, but maybe you can address that question first. And the second question is, on our lake, we had one of the main tributaries. We had a beaver dam way upstream in the mountains, and it broke and created holy hell for the lake. I wonder if you had any ideas on what should have been done then and what we can do now to prevent it from happening again.
Yeah. Yep. So your first question about how long a beaver can live in an area. Yeah, it varies greatly on the site. There's some locations that there's just so much food, beavers could live there for a decade or more. Other sites, you kind of get more turnover. So beavers will be there for a couple of years, then they'll abandon the site and move on somewhere else. We have a healthy beaver population throughout the state, so we're seeing that a lot of the good quality habitat is being occupied. So then those dispersing juveniles are kind of being forced into those less than ideal locations, which often ends up being around our infrastructure at road culverts where, yeah, there may be some food there, but it may be really challenging to allow beavers to live there if they're impacting our roadways. And then as far as your second question, yeah, that's definitely challenging. And I don't have a good answer for it. There's really no way to prevent or evaluate, I guess, the possibility of a beaver dam breaking. And beaver baffles themselves don't really reduce the chances of them breaking. They can help control the water level, so there's less water flowing downstream if it happens to break. But yeah, it's just kind of part of that natural cycle. So we probably have tens of thousands of beaver dams or more across the landscape in Vermont. And unfortunately, we hear about the ones that break and cause damage, but we don't hear about, or the ones that don't have any issues. They kind of complete their life cycle without creating any issues. We don't really hear about them. So yeah, I don't really have a good answer on like how to prevent that going forward or how to manage that.
We have one more question here.
Thanks so much. That was great. I'm just wondering, so I know that beaver wetlands are really important for flood resilience, and I was just wondering, in the wake of the floods these past 2 summers, if there's been any research or just like anecdotal evidence about the role of beaver wetlands in flood resilience after the storms.
Yeah, I don't know of anything specifically related to Vermont or like the July storms that we've had. But yeah, we definitely know through past research and just observation that these wetlands are incredibly important. We have Vermont Fish and Wildlife owns a number of parcels along Otter Creek, kind of Rutland to the Middlebury area, and right now even still those areas are underwater, so they're areas where the river is allowed to overflow its banks into that floodplain, and there's plenty of wetland habitat in there, and it's absorbing a lot of water, and because of that, really, like the flooding in Middlebury can be reduced or is reduced because Otter Creek is able to disperse so much of that water kind of further upstream. Whereas if it was all developed through there, that water is just going to kind of be forced to continue to flow downstream, which can create a lot of issues for folks.
Do you have any more questions? Oh. Okay. Tyler, there's a couple questions in the chat, and maybe you can add those, respond to those in the chat. So because it's a little short. Is there another question here in the audience? Okay. Thank you, Tyler. That was great. Thank you very much. Really interesting.
You're welcome. Thank you.
Okay. I learned a lot. Our next speaker is Erin Rogers. Erin is project manager with Trout Unlimited.
Oh, okay. Oh, interesting. Okay, cool. So yeah, good afternoon. I'm Erin Rogers with Trout Unlimited, and talking about the role of large wood. I don't know if you can even see me over your computers. All right, go ahead. Maybe. Sure. Oh, it does work. Yay. All right. Obligatory picture of me cutting down trees, adding large woody habitat. So kind of the way I look at streams and stream processes these days is kind of, you have to start with a little bit of historical context for kind of how we got here. Long before we started to really develop these areas, streams used to be fairly curvy. They used to be multi-threaded channels. They used to flood fairly regularly, and the areas around those were pretty adaptable to that kind of situation. However, development loves a straight line. And so we made them as straight as possible, maybe some nice 90-degree curves in some areas. And that's really impacted kind of our situation as we get here today. Not only do straight channels are actually shorter than curvy channels. There's less distance to get from this elevation to this elevation. So you're actually making a stream channel steeper. And the steeper it is, the faster that water is going to flow through there. When you take out large rough materials like large wood or large boulders and things like that, you're taking out anything that might slow that water down even further. So the more you kind of pick up speed with water, the more material it's going to end up moving. And it's just kind of create a bit of a feedback cycle, in most cases, a kind of a negative one. And we get to the conditions that we see on the other side of the screen here. So kind of that historic part would have been that stage one. But as we straighten things out, sometimes we dig out the streams, sometimes just straightening it will kind of create that higher velocity that will dig itself out. And then after a while, these banks get high enough that they're no longer stable, and they'll start to collapse into the stream and create a new little set of floodplains, but it's not nearly as much of a floodplain as we saw up here. And now, instead of being the groundwater and levels at the tops of that landscape, now we've got water levels that are a lot farther down, but we've still got forests and fields and things like that having to reach that much farther down and working a little bit harder to get to that groundwater that it once had a lot more readily available. So it kind of, there's a lot of things going on within that stream landscape. And when I first started working in streams, a mentor of mine always used to say the plumber's rule of stuff always flows downhill. And that is especially true in streams and especially true in straightened streams that are moving really fast. So we don't necessarily see how much material a stream is moving at any, during normal flows, during high flows. During really high flows, there are a lot of people that will say that, if you're standing near a stream, you can hear the boulders moving downstream. And that is absolutely true. But even when it's not those really high flows, those small particles, your gravels, your cobbles, your sands, they're still moving. They're still kind of processing their way down the stream. And there are, of course, all sorts of, fun geofluvial graphs that you can find that tell you, where gravels and sands are coming from and moving through and depositing in. But chances are also pretty good that you can walk along a stream channel and start to pick those spots out yourself. Erosion is really good at, or is really easy to, people are good at identifying these days. And once you start to see where sandbars are forming or where, culverts are starting to get plugged up by sand and rocks and things like that, those are your depositional environments. And it all kind of works together. And a lot of the times when people have reached out to me at TU about issues with their ponds and particularly with their trout ponds, one of the first things that is almost always cited is this pond just keeps filling up with sediment and material, and we want to get that out of there, which is understandable. It's natural for these ponds, if they've got a lot of streams coming in or even just one main stream coming in, if they're in the state that so many other streams in New England are in, they are moving sediment down through that slope and into that pond. That's their settling area. That's their depositional area. And while once it's there, there's really only a couple ways to get rid of it. One of the things that you can absolutely do is find ways to keep all of that sediment from moving into your stream in the first place. By starting to restore some of those natural stream processes that we have over time taken away. So that kind of gets to the kind of low-tech process-based suite of methods that that I use in my work. And, you know, I have field teams out even now, putting large wood back into streams and starting to reset and restore some of those stream processes that we've really started to lose. And so that includes everything from strategic wood addition, as we call it in Vermont. If you look in the literature, it can be anything or called anything from large woody material, large woody debris, chop and drop. It goes by many names. We consider, at least especially in Vermont literature, that we are a lot more strategic about it than just chopping and dropping away. So we gave it a new acronym. Additionally, there's post-assisted log jams and beaver dam analogs as well, when we don't have beaver already present in a system that we would like to. And all of this kind of goes back to putting roughness back into a channel, putting habitat back into a channel, and it has a lot of co-benefits from there. So really, it's all about location for where we choose to do a lot of these different methods. So with strategic wood additions, obviously you need to start with a pretty good forested area to cut trees back into that system. All of this kind of work is, as its name implies, very low tech. We don't use big heavy machinery. We are not cutting large swaths of anything. This is all done with hand tools and small groups of field teams. And generally with strategic wood addition, we use chainsaws and grip hoist, so which is like a very large come along that can pull, you know, huge sections of trees to create somewhat stable log jams within a channel, generally working in areas, you know, 25 to 30 feet bankful and less. Beaver dam analogs we have found to be incredibly useful in current and former agricultural fields that don't have necessarily any kind of large woody buffer that we could even cut from. But it's either got smaller woody material nearby or material in an upland part of the same property that we can cut and kind of bring down in smaller quantities. It works really well with deeply incised channels and that have not started to collapse quite yet, and even some of the ones that have started to kind of collapse in on themselves. And it works with a variety of substrate types. We initially thought kind of bringing this methodology into New England. It originated very much out on the West Coast, you know, Oregon and into the plains, where they have a lot finer soils and not so much boulder and, you know, large materials to work against. But even in those kinds of substrate types, we have found it to be very effective. We sometimes have to adjust our expectations of what size of materials we are using, but those BDAs can still be very effective across a lot of different substrate types. And then post-assisted log jams can work in either small or large channels, but really we've kind of focused those where we know we've got some high velocity situations coming down. It could be a smaller channel on a steeper gradient, or it could be a little bit of wider channel. They don't necessarily have to span the whole channel either. You can do bank attach so that you're collecting or creating really varied hydrodynamics so that you're catching sediments in some places, you're kind of pushing the velocity of the stream back and forth a little bit and creating that complexity in just a slightly different way. And some kind of key points for all of these is that, you know, they're wood. They are known to be temporary structures. They are not permanent solutions by any means. They might get buried by sediment entirely. They might get washed out. It kind of depends on what the weather conditions do in any given year, which, as we have seen, has varied wildly. The more structures that you have working together in a reach, the more effective they are. So yes, we can do this kind of work in a 1,000-foot stretch of river, but if we do it across 2 miles, it's incredibly effective at slowing water down, at spreading water out into that forested floodplain, into increasing fish populations, macroinvertebrate populations, semi-aquatic organisms, lots of things love wood back in rivers. And one of the things that we have also found working across New England, not just in Vermont, is that, during those, early winter and especially then, your spring months, the wood being darker colored than the snow creates a little bit of solar gain. And you actually can mitigate, or in sometimes, not all the time, but we have seen some instances where it's either broken up ice a little bit earlier than in surrounding areas, or just reduce the incidence of how much anchor ice is really building into those gravels. And from a trout side of things, excuse me, trout spawn in those really good, clean, pea-sized gravels. And if there's a lot of anchor ice that then tears apart those pea-sized gravels through the winter and the springtime, that can really affect the next year's population numbers. So having that, again, that diversity in habitat and availability and reducing some of those, potential negative impacts through different weather conditions really helps to increase the resilience of our fish populations. And these are just some of the schematics that we use. Everything that we do is kind of based on, here are our typical designs. And we use that as a basis to describe the work and describe what things can look like. But it's also incredibly dynamic work and very much depends on the forest, the conditions, the trees that are available, everything else that's going on. So it's very highly flexible, read in the field kind of a situation. So some great examples. So this was actually some of our early work in, this is maybe an 8-foot wide stream, so not even particularly big, not moving a huge amount of water. And this was in 2015, which was a drought year, so that made it a pretty interesting challenge, not knowing where the water necessarily needed to be broken up. But again, you can see it's a very uniform channel shape outside of the wood that we placed in there. It's kind of rectangular, trapezoidal forms, a lot of fine materials that have, eroded on the sides there. And then once we get some water, the amount of sediment that has now caught up behind this, as well as small materials, is really the kind of condition that we're looking for afterwards. As these large wood treatments can collect that fine material, especially like that leaf litter in the fall, that's really great for your aquatic invertebrates. So there's different aquatic and macroinvertebrates that shred leaves, that will eat bacteria, that will do all sorts of different functions. And so creating more diverse materials that are being collected in the stream really benefits the diversity of your little, macroinvertebrates that are feeding everything else. Same stream on a different section, again, that really uniform shape, nice and straight, coming right along the side of that valley wall, with a little bit of material that's, wedged under the undercut over here and kind of pinned between some roots on the other side. It's collected enough material behind that it's actually started to push out into that floodplain. I mean, this is, normal spring flows, so this wasn't even like a high, water event necessarily. But starting to push out, starting to slow that water down, trying to, create that habitat diversity that will, eventually make a longer, more sinuous line for that stream. Another example of the strategic wood additions on a bigger stream. So this is one that's about 25 feet across. But again, that same very uniform channel, very straight lines, pushed up against the side of the valley wall, even though, there's available floodplain to the opposite side there. So this is before treatment. This is right after we cut in the treatment. And so this is 2 years later. Things shift, things move. It's been hit by a couple of storms by that point. We've had some winter, some spring flows. And now we've got,
bars forming here, some fine sediments recruiting just up behind, a really nice plunge pool. So it's creating depth, it's creating dynamic flows. There's definitely evidence, it's hard to see from this far away, but there's definitely evidence of just how far it had regularly come out onto that floodplain. And that's exactly the kind of elements that we want to see when we come back and monitor it. For beaver dam analogs, and these can be, created in a lot of different ways, both with posts or without posts, using small material, using larger material. But this was obviously an agricultural field, as you can see on either side, no riparian area to speak of. And that's probably a 6-foot drop between the bottom of this channel and the top of the field, or top of the bank side of the field there. So with we staggered these fairly close together because it was coming down at a pretty steep angle to try and build some of that up. And so again, a couple of years later, how much of that has really filled in? I mean, this is one of those steps that's now completely filled in with sediment, both upstream and downstream. And again, just starting to really grade to bring up that bed so that this is now, now it's maybe at 5 feet instead of 6 feet, but over time, and continued treatments, if the farmer chooses to do so, that can, again, bring that whole stream channel up and make his crops work a few feet less hard to reach that groundwater, especially during those really hot summer months. Same stream, different section. So here we used the post assist, or the posted beaver dams. So we didn't have even larger material to cut from in the area. So smaller posts that were driven into the stream bed, using small materials to weave those in. And again, starting to retain a lot more water behind those, a lot more sediment, a lot of good material. And these were really effective in, this was not nearly as deep set into the channel. So we actually had a lot of really nice widening, a lot of multi-thread kind of channels starting to form through that whole area. And the vegetation change over the next couple of years and how green that was immediately surrounding that stream was really marked. And then BDAs in larger channels, because they are possible, they need to have very much the right conditions and very low slope areas to make sure that they don't wash out. And it takes a lot more effort and a lot more small materials to do, a beaver dam analog across, a 30-foot channel. This was a great example, actually. So this was in the Green Mountain National Forest outside of Somerset. And we went back to monitor just 6 months later in the fall, and a beaver had actually already come and colonized that one. So he was swimming around behind that. He had actually already started to build more material on, we are not nearly as good at this as they are. So he was doing his thing and making it look, so much better than we could. But it was a great way to kind of seed the environment, and maybe he would have built there anyway, but maybe we gave him a little extra opportunity to build, where he wasn't going to disturb any other landowners. And here's a great example of some of our post-assisted log jams. It's a little, they're messy. A lot of this work is, in fact, pretty messy when it first starts out, but it starts to naturalize pretty quickly. So we've got some of these larger, longer posts, or log materials that are posted. So 3-4 inch diameter posts that are maybe 5-6 feet long to start, and then they're driven down into that substrate. Because this is, it's a wider channel. This is maybe 20-25 feet, but we get some really stronger flows through there. And so if you see, there's that rock there is the same as that rock there is the same as that rock there. And so it's really bony material when we first started. It's a lot of gravel, or it's a lot of cobble, it's a lot of boulder. So this was, a few months later, and then by that winter, you can see the change in sediment. So that's a lot more fine materials, that's a lot more gravels. And so this is where we've actually been able to come back and found brook trout reds where we probably would not have found them before. Again, same channel, different area, where we had, put in some large wood, posted it there. And so you've got how kind of sunk in those two cluster of trees are and how much more sediment has collected up under those and really brought the level of that stream channel up a little bit more. And so kind of the takeaways for how, the large wood can really benefit lakes and ponds is really, slowing the water down, spreading it out. That's going to be, your flood resilient areas across the board, whether it's going into a lake, whether it's going into a larger river. But they're really effective at retaining sediment upstream where you want to keep it. It's really good at engaging your floodplain forests where you want to keep your floodwaters and not in somebody's backyard. By retaining a lot of those sediments, especially their smaller sediments, there is growing evidence that this is, retaining a lot of those nutrient inputs in that higher part of the watershed and not affecting your lakes downstream. And then the forests get to take advantage of that, which is great. You get a lot healthier floodplain forests when they have, regular inputs of all these fine sediments. It reduces the need for any kind of dredging to maintain your lakes and ponds. And obviously it improves a lot of habitat for aquatic and semi-aquatic organisms. Otters love this, all sorts of things that, so we do a lot of monitoring with trail cameras. And while I haven't included any, I didn't know everybody else was gonna have trail camera photos and videos otherwise. But we've got some great pictures of all the different species that use these big, large wood structures just all over the place. Actually, one of our installs in Maine, we have a picture of a Canada lynx crossing, which is like one of my best pictures. It's a really terrible picture, but you can tell it's a lynx and it's, a little bit of victory there. So that was really exciting. And yeah, just the number of benefits to really restoring the stream process can help everything, surrounding the actual work and downstream of the work. And that is the last one. So any questions?
Hi, thank you so much. Excellent work. Love to see it. I'm curious, what would you say the percentage of your BDAs have with returning beavers? About all the BDAs that you make, have you seen a lot of beavers return and take up lodging and space?
Honestly, in the smaller streams that we've used them in, very little have been colonized by the beavers. But in the larger places where we have been able to put them in, mostly in the national forest, they have a probably 50 to 60% colonization rate on them. Yeah.
I have a question from Kelly. Aaron, under what conditions would you want to install a BDA or PAL, excuse me, in such a large channel?
At this point, we have largely done the BDAs in remote parts of the national forest where we know that they are not going to affect any surrounding infrastructure. They are well outside or well upstream of any bridges or culverts or anything else that might be affected, so that if there is failure, it's not going to have a substantial effect on anything else around it other than the forest and the critters that are already going to, be utilizing it. The post-assisted log jams, we have actually had the best success rate in using those in combination with dam removals. So very particularly putting them downstream of dams where we know sediment is going to be moving downstream at a higher rate than it might otherwise be. And especially around dams, which Karina's going to talk about next, you've got that really high, you've got one side that's really low and one side that's really high, and then the river is trying to find its new slope. And catching some of that sediment on the downstream side actually softens that slope a little bit. It brings that downstream channel up at the same time that the upstream channel is coming down. So it just kind of eases that change, that rate of change for rivers.
There's one more. Aaron, how do you address community stakeholder concerns around adding wood to a system when wood and trapped debris near infrastructure seems to cause a lot of visible challenges during the flood events in the past 2 years?
Absolutely. And that is a perennial concern that we are regularly talking about. And it's a bit of a balance. So we will not put any large wood within 1,000 feet of a structure, especially an undersized structure. But we also upsize undersized structures. So that's kind of we do pair in-stream habitat work and large wood work with dam removals, with culvert removals, so that we know the structures are, or that there won't be any, there will be a lower risk to the structures around them. So we give them that wide buffer, we upsize structures, because it's true, the vast majority of culvert failures, and this is true across the United States, across countries, is not that culverts are overwhelmed by water, but that they are clogged by small debris, by large debris, by rocks and sediment that are moving downstream during that flood too. And then they become dams, and then they get overwhelmed. So we don't want to contribute to that. But there is also a recognition that during a 100-year storm, during a 500-year storm, even during a 50-year storm, a lot of material is already moving downstream. And we have, between TU and Vermont Fish and Wildlife, we have done over 50 miles of strategic wood addition in the Northeast Kingdom alone, in the Nullhegan kind of drainage, which has been hit by 2 major storms in the last 2 years. And Judd Kratzer, the fisheries biologist up there, has done an amazing job of going back out, of monitoring all of this work. And the stability rate of our large wood structures, especially again in those longer reaches where you've got that, you know, that additive effect over space, the stability is huge. We have found, or Judd actually went out and measured, and it was something like 300 dump truck loads of sediment that were retained behind these during the floods last year, that didn't move, that didn't go into town centers, that held up really well. Because once you start to embed this large wood and put sediment over top of it, it's not going anywhere. Like, it becomes a part of the stream, which is great, which is exactly what we needed to do. And at least, while it has always been very nerve-wracking to see your work put to the test of multiple repeated large floods, it's also really nice to see how effective it can be even in the worst of circumstances. Yeah.
I'm curious about the, if you were to propose doing strategic wood addition in the Green Mountain National Forest in headwaters to help protect your lake, what would the permitting process be for that?
So we work really closely with the Forest Service on doing strategic wood additions throughout. And the way that the Forest Service typically permits things is they work in integrated resource project areas. So they kind of look at everything within a certain area, and they'll permit everything all at once, and it'll be like a huge 5-year process, and they'll do all of the hard work at once. So if your lake is within one of those IRP areas that has already had everything permitted for it, you're in the clear and can basically walk in, or, you know, funding in hand to pay for such work. And, you know, we work with the Forest Service quite a bit, so we have kind of permissions to do certain things. Like, that would be an easy ask. There is a mechanism for identifying and requesting permitting for smaller one-off projects. But it's a lengthy process, and can be a number of years to go through the Forest Service NEPA kind of permitting to make that happen. And there are plenty of times when they have looked at projects that were kind of those one-off things, and unless they're really good projects, there are plenty of times where they've said, no, it can wait until we do an IRP for this area, and it can be wrapped into that process at that time. So it's a little bit of a give and take for Forest Service land. All right.
Wonderful. Thank you so much, Erin. That was very, very interesting. So we have a break scheduled, but let's make it short, maybe 7 minutes, for everybody here to be able to stretch their legs for a couple minutes. And so we'll be back at 2:47. Okay. We're just about to start. So I'll just, there we go. He's got yours coming up.
I'll move through to try. I mean, I think I have 20 slides, but I'll try and move through all that.
Well,
'cause
whatever.
I know
Sure.
there's one more.
There's one more after you, but that's okay. We started
Tight
late.
schedule.
Well, Hey, hi, everybody. I think we're back and we're ready to go. Okay. All right, we're back. I am very, very pleased to present our next speaker, Karina Daly. Karina is a restoration ecologist with the Vermont Natural Resources Council, and she's also chair of the Vermont Dam Task Force. So, Karina, you're on.
Thank you. Can you guys hear me okay? Awesome. Well, it's great to be here and thanks for hanging with us today. I'm at the end of the conference, so I will move through my slides a little bit quicker, or try to, because I have about 20 slides. But really, I just sort of want to share, first, I think it's really exciting that the FOVLAP is doing thinking about the rivers entering the lakes and the restoration work that can be done in those as it relates to water quality in the lakes. So thank you for that. And so yeah, I'm going to share a little bit about what I do, why I do it, how I do it, and then where I've done it. So some stories about that. And I'll just move through the slides. But yes, I will say I work as a restoration ecologist. My background was an environmental consultant, wetland scientist, wildlife biologist, and then I also wear the hat of, I am on the Citizens Advisory Committee for Lake Champlain Basin. So I'm also thinking about the quality of the Greater Lake, and I work on water policy at the state level. So it's really fun to be able to do this restoration work on the ground and see how it informs the policy work at the state level. And I will say that we have a website, Free Vermont Rivers, which is a great resource that is something that is a product of the Vermont Dam Task Force. And you are welcome to go to that website and learn more about dam removal. So to be continued. Let's just see if I can advance my slides. Oh, I have to go this way? There it goes. Perfect. And another goal of the Vermont Dam Task Force was something called the Vermont Dam Removal Initiative. And this was created as a way to raise awareness about derelict dams on the landscape and identify those dams that need to be removed, prioritize them, and collaborate with all the different stakeholders that are doing this work. And I should say that I manage the dam removal program for Vermont Natural Resources Council, but that's not because I want to remove all the dams, derelict dams in the state. It's because I want to help support watershed organizations do this work. So I'm a resource for others and trying to build capacity because we have well over 1,000 dams in the state, and many of them are derelict in the hundreds, and we're finding more all of the time. And so we can't get this work done fast enough with the amount of flooding, storm events, and barriers to fish passage and impacts to water quality that we're finding. So really helping to raise that awareness is a goal of the Vermont Dam Removal Initiative. And I will say that in the years that we've been doing this work, and this work far surpasses my time doing it, we have physically removed 72 dams from our waterways in Vermont, which is really exciting. And American River says that Vermont has removed more dams per capita than any other state. So that's pretty cool. You've already seen this graphic today, which is really exciting, so I don't need to go over it too long, but I am going to reiterate it because when we remove a dam, I think most people think we're restoring the longitudinal connection to a river, so that up and downstream thing. But I'm here to share with you that we're actually restoring all of the connections. So this is a fundamental concept of watershed science, that rivers exist not in one dimension, but in 4 dimensions. And that longitudinal connection is, when you have a dam, it's blocking, it's fragmenting that system, so rivers can't transport nutrients and sediment and water and wildlife. But you're also, when you have a dam, you're impounding water behind that dam, and that is blocking the river's access to its historic floodplain. So that's that lateral dimension. When you have a dam in a river, you are also disconnecting groundwater to surface water, that connection of that groundwater moving downstream and feeding that river system. And then that temporal dimension, which is that rivers change over time. We've been talking about this all day today, is giving them the space and time they need to move is critical. And we need to understand that change is a river. This is from the Stroud Water Resource Institute, and it's a graphic that we use a lot in talking about dam removal. But again, you can see, and it's called the river continuum concept. And it's this idea that rivers depend on biota, flow, and habitat. And that is a cycle that is a river. And we need biota, flow, habitat is the continuum of a river. And when you put a dam in that river, you change that continuum, and you have sediment building up behind that dam. You have the substrate changing, so the sediment's sorting in a different way than it would naturally when it's flowing downstream. The temperature behind that dam warms up. You have less turbidity. Your dissolved oxygen lowers, so you really are changing the ecosystem to something more lake-like than riverine. And the species change. You have warm water fish species versus cold water fish species, which is what our Vermont tributaries are known for, those eastern brook trout habitat. So the unintended consequences of these derelict dams in our waterways in many cases create something like a bathtub. And it does raise the temperature behind that area. And this isn't all dams. We have very many different cases of derelict dams in our state. In addition, the substrate changes, like I spoke to. We have fragmentation of the landscape of the river system and what that does to aquatic organisms. And there's an increased likelihood of invasive species within that system. The picture I just wanted to share, those are long-nosed gar right below the Swanton Dam, blocking. So this is in May during spawning season, and these long-nosed gar are actually right at the face of the dam. So they're kind of funny looking, but I do like that picture. And the benefits of dam removal is restoring that lotic habitat and the thermal refugia. So it's really important for these cold water fish species to move up a stream to find those cold water habitats where they can hang out during warmer portions of the season. And that habitat diversity that they can access. So increased access to habitat diversity, genetic connectivity, resilience, and floodplain reconnection. So now a little bit about how we do this dam removal process. I'd love to say it was 10 easy steps. Many of these steps are repeated many times over the course of projects, but I am going to focus on a few steps as we go through it, project selection, fundraising, outreach, and removal. But a lot of times we're cycling back to developing more support for the project as we get through each phase of the project. So it really is reiterative in a lot of ways. And with project selection, we are looking at multiple things, and it really also depends on the funding that we have available. But ecological impacts, so aquatic organism passage, flood mitigation, wetland restoration, and water quality benefits. The hazard potential classification of the dam, so we can have a high hazard dam that if it fails, it would take out communities downstream and impact infrastructure downstream. But we can also have and the hazard classification of a dam isn't the quality of the dam. The dam can be in poor condition, but a low hazard, because if it goes, it's not necessarily going to impact anything. So those are two different things. Owner interest, we can't take out a dam unless we have ownership interest. So we can have a high priority ecological dam removal, but if we don't have support from the community or the landowner, then we can't move that project forward. And our projects only move forward without support from so many partners. So that's a huge piece of this project and how we move them forward. And this picture shows a dam removal that we did in Rutland, in the city of Rutland, Dunkley Pond Dam. The dam was sort of where that truck is in the background. So we're looking down, looking down at where the dam historically was, and you can see this floodplain that we've reconnected here on the right bank and the plantings that are happening there. These are just some of the many partners we have. Trout Unlimited should be on here, and they're not. So I think this was from Wainwright, which was a dam removal we did last year. So this is just an example of some of the many partners we work with, but there's a lot of stakes at the table and a lot of people interested, and that's great. But it does keep the project moving at a pretty slow pace. But it's really important to build the support. And then the fundraising piece is really tricky, and it really depends on what the characteristics of the dam. But we have funding in 3 buckets: water quality funding, flood resilience funding, and aquatic organism passage funding. And sometimes our dam removals meet all of those criteria, and those are really great projects, and some don't, because it's a waterfall. It was historically a waterfall and bedrock, and it's not going to meet fish passage necessarily if we take out the dam. But it is going to provide a reconnected floodplain upstream, and will have a tremendous flood resilience benefit. So it's great when they do meet all those criteria, but sometimes they don't. So it is always a puzzle to find all the funding that we need. There's less funding than there are projects, certainly. And you need to leverage the funding to the best of your ability. So if you receive federal funding, then you need to match that with state funding and ultimately local funding as well. So it's really and then you're fundraising for first potentially the feasibility study, and then the design of the project, and then the removal. So it's not even funding the project, it's funding the first phase of the project in multiple phases. But I will say that the urgency after the 2023 and 2024 flood events has been real, and there's been more work than ever, and my phone's been ringing more than ever. So there's a silver lining in that. I think a lot of people began to connect the dots on that they don't want the liability of having a dam in their backyard or above their community. And so how do they move forward? And the good answer is that there is funding available and support to do this, and it often doesn't require, the landowner having to be involved at all if they don't want to be. Certainly the best projects are when they are, but we can raise the funds and get it done. We can't necessarily get it done fast enough, and there are certain projects that literally, were impacted. They failed during the flood event of 2023, and we still don't have those dams removed. And they cause quite a bit of damage to different towns. So I'll go into that later. But this just shows some of the engineering and design process. We typically, I would say with dam removals, we break them up into a feasibility study. Then the design can be broken into 30%, 60% final design, or depending on the size of the dam, we might just go right to final design. And then obviously permit the project for removal or construction, which is the implementation. And I will say there's not enough water resource engineers out there for the amount of work that's needed in the state. So it's a really sort of select niche area. We held a workshop last year trying to train with the goal of training more engineers and contractors to work in the water and do this type of work. And we're trying to address that bottleneck, but capacity is limited. And but it's exciting that it's happening, and I think more people are getting trained up. So then we get to the removal phase, which is the most exciting, and that's when the big yellow equipment comes out and we're working in the stream, and there is a temporary disturbance for a long-term benefit. And it is, again, trying to restore the channel's dynamic equilibrium. So if we've had a dam in an area for 300 years, you can imagine how that upstream channel has changed and how the sediment has changed in that area. And so we're trying to recreate what was historically there. And it's a balance of letting some of that sediment go, if it's clean sediment, and letting it feed the banks downstream that have been nutrient starved for hundreds of years, and removing that sediment so that not all of it goes down in one big flush, and that we're managing that in a controlled way. So that's why we have the equipment, and the expense of these projects isn't so much in knocking down the concrete dam, it's in taking the sediment out behind that dam and finding the historic channel, because that sediment has to be trucked somewhere off-site and stored, and we have to identify that other site, make sure that that's away from a wetland and historic areas. So it's really thinking about the project, not just on the scale of what's in the river and the restoration of that, but also where that sediment's going and the quality and character of that sediment. In some cases, the sediment's really great for road base, and towns can use it. So that's pretty cool when it can get reused. And you can see Erin's actually in this picture here. This is Wainwright Dam removal that we did last summer in Salisbury on Tributary 10 below the fish hatchery off of Lake Dunmore Road. So this, I'm just going to highlight some of my dam removals. This is Dunkley. I showed you a picture of it earlier in Rutland. And this dam was removed in 2021. And this was a dam that both had water quality funding, fish passage funding, and flood resilience funding. But I will say that the fire chief for the city of Rutland had evacuated 3 homes in the community, or down right by this dam, 8 different times during full storm events following Hurricane Irene all the way till 2019. In the fall of 2019, there was a Halloween storm event where they actually had to breach the dam because of the flooding was so bad while they were evacuating. And following that breach, we raised the funds to fully remove the dam. And this one's just been like a super success story for the community, because suddenly all these homes that were having to be evacuated constantly are safe. And the floodplain's been reconnected, and it's on Tenney Brook, so the main stem of Tenney Brook, which flows through Rutland. And it's been a great project for that. And if you're ever driving up Route 7, it's right across from Rotary Park in Rutland. And this sign on the left, I just wanted to speak a little bit to the historic piece of these dams, because many people are very connected to the historic character of the dam and its existence. And as through the permitting for dam removal, we have to document all of the historic history. And actually, we often find much more history than anyone ever knew with the historic preservation requirements that we're required to do. And in many cases, that involves leaving some historic remnants of the dam, so like abutments, or we'll turn some of the stone pieces into a bench, and then we'll put up signage. And the signage tells an awesome story of how, what the dam provided to society during the use of it for hydropower, but also about why we're taking out the dam and what may have existed before the dam was there. So I like to think about the history not just starting with the Industrial Revolution, but also with the 13,000 years where Native people used the land and moved up and down those river systems for transportation and food. So that's an example of that, and it's been fun doing that research. This is a dam in Castleton that we removed in 2022, Pelletier Dam. This is a Vermont Fish and Wildlife Service owned project, and it was a pond that they bought to be a recreation fishing pond for the state. And of course, after it had been a marble mill and also an ice pond. So a lot of these have been mills, and then they've been ice ponds, they've been recreational ponds. Of course, the recreational pond filled up with sediment because that sediment couldn't move downstream. And so it wasn't much of a resource for a recreational pond. And they identified that it's like an awesome brook trout fishery, North Breton Brook. And the benefits of removing the dam were far greater than keeping the pond. So and it was a beautiful dam. It was marble, all marble, brought in by oxen from the, I think from the river, is it the Castleton River, I think, downstream of that. So they actually like floated the marble down the river, and then the oxen walked it up to this tributary to build the dam for the marble mill. But this dam removal reconnected 32 miles of fish habitat, eastern brook trout habitat. So really awesome restoration story. And this is a headwater, this is a NRCS dam. These were actually NRCS paid folks to build these dams in the, I think, 1950s and 60s for water supply. So this is a big earthen dam, like 300 feet long. And this is up in Shrewsbury and a headwater to the Mill River. And this dam actually was threatening downstream infrastructure, a home and a road, a highway or a town highway. And so we had to do, and it was failed because the landowner didn't really realize they had this dam that they needed to maintain. So they let trees grow up on the dam. Not a good thing if you're trying to maintain a dam because the trees break down the earthen dam. So we had to do an emergency drawdown to keep the infrastructure, to protect the infrastructure downstream because the dam was failing. So we drew down the pond in 2022. And before we were able to remove it in 2023, this is what came up. So this is a drone footage after the drawdown, but the dam is still in place. And it just, I love this picture because it shows the headwater wetlands and seeps that are feeding this stream system so high up in the watershed. And that was all underwater. Like you couldn't see that. And definitely we restored this like wetland complex that had been submerged for 50, 60 years. So we did ultimately remove the dam. You can see the outlet on the right-hand side and reconnect this tributary with the Mill River. And then this is last year's project, which is Wainwright Mill Dam in Salisbury on Tributary 10 below the fish hatchery. And this, again, had the similar history of being like a tannery, an ice pond. It was used for the creamery, the local creamery, and was also a trout pond and had been abandoned for the past about 100 years. And we removed this dam, and this one had a fair amount of sediment behind it. It also had about a huge beaver complex above it. So part of, and I'll show you, I think the next picture is, oh, maybe not. Well, I'll just share with this one. So part of our permitting with Agency of Natural Resources related to sediment. So this was in an impaired tributary. So it also elevated the project because we're working in an impaired tributary. I believe the impairment is related to the fish hatchery upstream, so that's complicated too. But so they were concerned that removing this dam and releasing that sediment would elevate the impairment. there still is that concern. So there was quite a lot of permitting requirements related to this dam where we had to remove so much sediment. And then we also installed strategic wood additions, PALs and BDAs, upstream of the dam to slow the sediment that we did leave on site and help enhance the system. And Erin and I went out there this spring and everything's looking really great. So the beavers are back. They were working on the BDAs that we had on the top one. So they're already using what's been there. We do need to continue to revegetate the site. So it was finished last fall and there was a little bit of flooding. So we're hoping some more vegetation comes in and we're planning a planting this summer, but an exciting project. Okay, I think that is almost it. This just talks about the evolution of the Wainwright watershed, which is a similar history from what I shared. And lastly, Cross Brothers Dam, which is a dam we're working to remove hopefully this year or next. It's currently in a FEMA backhold. But removing this dam will lower the flood elevation for 10 homes, which is pretty substantial, by 2 feet. So excited for that. And this is my last slide, and it's just all the great things that happen with these projects. We improve water quality, we restore natural stream process. It allows for increased flood resilience, wildlife habitat. It provides public safety and recreational opportunities by reconnecting the river, and an improved understanding of how rivers function and support for local watershed organizations doing this work. So thank you.
Thanks, Karina. I always love to see you present. I had a question. Erin said, I think when she presented, that they were putting BDAs and SWAs, PALs, below where the dam was going to be removed. And then you said you did yours above. So can you explain like why you did yours above and why? Yeah.
Yeah, I think it's different on different sites. And so we did ours above because of the sediment that had basically impounded behind that dam over time, 300 years of sediment. We're only taking out half of it, so we're leaving some. The state is concerned about that sediment moving downstream and not feeding the banks that have been sediment starved right downstream, but ultimately impacting further down the watershed. So we put in those BDAs and PALs upstream to slow that sediment and capture that sediment in that area. But I think downstream, or what we did downstream to capture sediment, is put in rock weirs. And those weirs during construction got cleaned out by the excavator. So as sediment was caught in those weirs, we'd clean them out and then build them back up.
There we go. Cool. Hi, excellent presentation. Love it. Thank you for your work. 2 questions. One, where are like the top 3 most common places that you deposit the fill that no longer can be used again? Just curious. And then a second question, I know that in the history of building dams, like various communities have parts of their communities flooded. And these are various communities of people, whether it be indigenous people or various low-income people. In the history of your dam removal, have you come across any of those histories?
Let me first one first, and then I'll try not to tough one. So Phil, there isn't really top 3 sites. Oh, sorry. There isn't really a top 3 site. Every project has been different. For Wainwright, the contractor who we hired, because we couldn't find a site, none of the farm fields were approvable based on historic concerns, archaeology, or wetlands. But the contractor had a permitted fill site, which was an old gravel pit. So that's an example. The one in Rutland, which actually had urban soils, which means there was some contaminants in those soils, they had to stay within the city of Rutland, so within the urban soils layer for that area. But the city could use them anywhere after they also had invasive species, so they had Phragmites, so they had to sit in an area for 2 years, and the Phragmites had to be buried 6 feet deep, and then after 2 years that killed the Phragmites, and it could be used anywhere within the city limits. So those are like 2 examples. And then I have not come across in like indigenous communities that have been flooded. I've definitely, worked with mobile home park areas that have been flooded like more recently in these flood events, but I haven't come across that in my research, but that's really interesting.
Thank you. Thanks, everybody. And now our final speaker. I am thrilled to introduce David Dean, former representative for many, many years. David is also a member of the Vermont Fish and Wildlife Board, member of the Trout Unlimited Board, and has been a tireless advocate for water quality and for the waters of Vermont. So welcome and thank you for being here.
Thank you. What is this? All right, that's the slide. I actually I'm going to try with this down. All right, I do have a fairly loud voice. In addition to yeah, that's plenty loud enough. In addition to some of the introductory remarks, and I thank you. I am also part of the Vermont Fish and Wildlife Connecticut River Anadromous Fish Cooperative. I'm on the board. I'm a citizen representative from the state of Vermont. I am with Trout Unlimited, and I want to thank BT Fitzgerald and Geo Peebles for helping found the dams task force. Everybody asks about a watershed, so I just wanted to include it so that everybody can see that's a watershed. And that dotted line, where's that dotted line? Great. And I touched the wrong thing. See, I knew I'd do that. There we go. Every drop of rain that falls within that dotted line is headed to your lake. I included this. This is a shot of the mouth of the Otter Creek after Irene back in August of 2011. And I included because I wanted to make the statement. If it gets in the river, it's headed to your lake. All right, there it is. It's headed to your lake. Difference between lakes and rivers move. And this is a time sketch of a small reach of the third branch of the White River. And it was mentioned earlier that sometimes rivers are at the toe of the mountain, at the edge of the valley. That isn't where they were originally. They were put there. 80% of Vermont rivers have been modified in one way or another. One of the favorite was to move the river over out of the valley so that you didn't have to cross a river in order to farm the field. So you have to be aware that rivers move, and several people have touched on that in their presentations. No. Oh. Okay. Where's? I need to move to the next one. Should be. Let me go check and see if it's got that. Here, so anyhow, oh, there we go. Rivers move. And it, do not build in the meander corridor. And anything that is in the corridor is going to make its way into the river. Do not build in the floodplain. It's been explained to you where the water goes when you have a high water event. Anything in that floodplain is headed eventually into your lake. And it's been mentioned a couple of times today with Lewis Creek and Otter Creek. During Irene, Otter Creek flooded in Rutland at 19,000 cubic feet per second. 30 miles downriver in Middlebury, the flow 4 days later, the river having picked up contribution from tributaries, peaked at 7,000 cubic feet per second. And it's already been mentioned, open ground, agricultural lands, wetlands, untouched areas within the floodplain. The other thing is urban areas. Any built up area is going to contribute things to a river, particularly if there is no riparian zone protection. And in this case, it's, we're going to touch on politics in a minute, but right now there is an issue going on called the 3-acre impervious surface runoff. It's important to you in your lake what is happening with that portion of law in cities in your watershed. Tile drainage. Agricultural lands, I think everybody's aware that ag lands can potentially contribute problems, phosphorus, nitrogen in the Connecticut River, phosphorus in Lake Champlain. But in my opinion, and this is important, tile drains should be considered a point source discharge to the waters of Vermont. They are not. They are exempt. Aggravates me. Sorry if I. Now, each of us individually also have some responsibilities for how we deal with vehicle waste, lawn maintenance, home improvement work. I love garage waste. I don't own a garage, but I guess some people do. And garden maintenance. And, you know, on the back table, I put some handouts developed up in Maine on 10 things you can do to help protect your lake. Everything on that list is true for rivers also, and please feel free to take one before you take off. Riparian buffers should be required. You know what the requirement is? Because we lost the political fight, 25 feet and you can harvest it. Okay? It should be 50 feet untouched. I'll go 100 feet, but I'm mimicking the federal requirements. EQIP and the federal programs is 50 feet. Where you don't have a buffer, you have erosion. And that's all there is to it. And with erosion, phosphorus attaches to soil particles. It's going to move in your river and it's coming to your lake. And there was discussion earlier about some of the plant activities and things that go on. Blue-green algae that closes beaches, purely a function of nutrient loading. And this is part of the problem if you don't have buffers on your land. Okay, and now the rest of the story. No more slides. Addressing the situation that I wanted to get to might take some explaining. And I'm going to start with simple, basic, why do we have government? The historical reason is to do things that we as individuals can't do, like build roads and maintain those roads beyond our driveway, maintain the military, legal, medical, educational means of defense to protect us, our property, and our progeny, assist us in our needs like hospital, emergency services, Social Security, education, and to protect our public trust resources, air, land, wildlife, and water. And why do we need to protect our public trust resources? I'll start with a refresher of the basic economic apocryphal story about the tragedy of the commons. The story goes that a village owned a grassy town common for use by all the village residents. Initially, a few citizens began to each graze their single cow on the commons. Then one neighbor thought, if I graze more than one cow, I will have an economic advantage over my neighbors. And he set out 3 cows. Soon a different villager saw what was happening and decided he was going to graze 10 cows. Soon all the villagers set out as many cows as they could to graze the commons, but unfortunately, there were too many cows grazing and there was no grass left for any of the cows. The tragedy of the commons describes the conflict between short-term self-interest and long-term common good. Here's a key role for government: to establish an agreed upon management of resources to make sure that they are available to the long-term benefits of present and future citizens. I ran 17 races running for elective office. I won 15. I served with 6 speakers of both parties, 6 governors of both parties. And during my tenure, I served in both the majority and minority in the House. Over those years, I co-sponsored and helped pass many environmental protection bills, including the Lake Shoreland Protection Act that allowed shoreland development and required protection for our lakes. Wrote the Clean Water Protection Act, Kent and I were talking about earlier, that established the required agricultural practices, as weak as they are in terms of buffers, established an independent funding, a clean water fund with an independent source of revenue, and established a river-friendly training institute for heavy equipment operators who work in rivers. Co-sponsored the Groundwater Protection Act that declared groundwater a public trust resource. And here's the point of reciting those acts. It took 76 members of the House, 16 members of the Senate, and a governor's signature to pass every one of those bills into law. And passing any bill requires a strategic sense of how to move those bills through the process. I mentioned this because I feel this is the challenge of how you take the next step in lake protection. I encourage you to get involved with politics. But first, in your own mind, replace the word politics with the phrase public policy. Politics is a matter of choosing what will be public policy. Now, how do you do that? You run for something, get appointed to something, engage in an issue publicly, or support someone or a group of someones who are willing to run for something. I grant you that getting involved has become more challenging with the political winds blowing in our country today. And of course, everyone already loves to denigrate politicians. But they're ignoring a basic fact to our republic, that an elected legislature and executive branch of government is how we establish public policy, how we make societal choices, how we establish and protect the values in our society. The election process itself is completely impartial about who is elected and what their personal standards for the environment, people, or government might be. It is a simple marshaling of enough votes to pick the member of the legislature or who becomes governor, senator, or representative. Public policy is a matter of who runs for office and the values they bring to the position. Based on my experience, I would offer that you already have a mighty set of tools at your disposal to marshal those votes for lakes and rivers. Your lake association is comprised of people with an active love of lakes and a sound environment. They are active in their associations and interact with neighbors, boaters, fishers, town, state, federal government in the interest of lakes. These are the people who want to protect the commons for the future. It will not be hard to organize them to electing people to positions that will take the steps necessary to protect our state's waters. And I wanted to mention Title 21, Section 496 in our labor law of our laws requires employers to allow people to serve. It's called the Right to Serve Bill. I was part of passing that way back. You got to notify your employer, but if you do, you're allowed time off and your benefits stay in place by the statute. Anyhow, to get yourself elected, you need volunteers to do mailings, drive for when you do door knocking, distribute your campaign information, donate time and money so you can tell your story, and hold your hand when things look grim. Remember, I won 15 of 17. I leave you with a request. Do not let the national, self-serving, dishonest, cruel, dysfunctional, tyrannical demons cloaked in political clothing dissuade you from participating in developing public policy. Keep historical Vermont leaders firmly in mind, like George Aiken, food stamps, Madeline Cunin, planning, Robert Stafford, a poverty warrior, Howard Dean, land preservation, Jim Jeffords, Mr. Integrity, and Patrick Leahy, Mr. Water. I will sometimes mull over Winston Churchill's statement. Many forms of government have been tried, and no one pretends that democracy is perfect or all wise. Indeed, it has been said that democracy is the worst form of government, except for all those others that have been tried from time to time. He is still right. I counsel you as we struggle to not allow the current DC misdeeds to deter you from participating in politics. If we are to have no kings, we must nurture our republic with active participation. Friends, we need all of you. Jump in. I can tell you from experience, the water is fine. Thank you.
Yeah, David, I was just gonna ask you a question about, in today's world of politics, the difficulty of a legislator making the right decision and trying to keep that individual's job. I looked at the Vermont legislature in 1990, or I should say 1890 or 1900, and the percentage of farmers, which I believe was close to 90%, and the farmers that would serve in Montpelier would go there with a 2 to 4 year plan and then move on. And I read quite a bit about how when you make a decision and not worry about being reelected, how that decision becomes much easier. And in today's world of politics, how do you feel? I mean, you were a successful long-term legislator that seemed to do it with still being able to make the decisions that you felt were important. But in today's world, how does that happen?
Well, and that's why I spoke about a sort of natural network. One thing politicians can do, all of them, regardless of R, D, I, P, whatever their name, the letter after their name is count. They can count votes. And when in fact an identified group of people makes it known that they want certain things, politicians will listen within a band of basic philosophy. But that you work out during the election process. We're not in the 1900s. We don't have farmers. One of the reasons that we passed the Right to Serve bill was so that we didn't have a legislature made up of my peers, people my age. We want young folks. We want people who are at the start of their careers, who know what is needed in order for them to prosper into the future. But one thing, once you're engaged, you learn to count. You learn to count the votes. And I wouldn't have had as long a tenure with my agenda had my district not supported me in terms of what my agenda was. Now, I had a profile. I was known to care about people. I was known to care about the environment. That was my message going in. That was the message that I carried. And what I'm suggesting is that people who run or have a notion of running, in this group, you have a built-in constituency who's going to agree with you and help you out. So you're looking to New Hampshire's a conservative state, right? Not when it comes to lakes, they're not. They love their lakes, and it doesn't matter what your political stripe is. You better protect your lakes in New Hampshire. That just, you don't, you're gone. So let's make rivers and lakes, let's make a treaty between those interests, and let's get people in to the legislature who have that as a priority. In the last 2 years, nothing has happened. Right, Ken? We were talking about it earlier. Nothing has happened up there because you don't have a river warrior. You don't have a water warrior who's leading the charge up there. Go out and find one, elect one.
Thank you so much.
Thank you.
This is great.
Have a nice weekend.
Thank you. That was great. Thank you so much. So we're at the end of the day, and I want to thank all of the speakers. I think it was a great day. Learned so much. I hope everybody's learned some things. And I want to many thanks to the events committee of the Federation, ably led by Jackie Sprague, our vice president. And most of the members are here. Jan Parsons, who was here, Jerry Bergdahl, I don't want to forget anybody, Dave Johnson, Laura DeLugalecki, Deborah Muccio, Jay White's here, who helped set up. Kent and Vince were here. Everybody, you know, is, who did I miss? Jeremy. Special shout out to Jeremy, who kept things going. And Dave Johnson, who's sitting in the back too, who helped put this together. Thank you all for all of that. Before I close, I just want to say how great it was to hear about so many interesting projects and so much work that people are doing. But we also heard about something else. We heard that 73% of the nation's lakes are now eutrophic or mesotrophic. Hypereutrophic, sorry. It's been a long day. We aren't there yet in Vermont, but time is not on our side. Time is not on our side. Phosphorus levels are going up. Aquatic invasive species continue to spread. Okay, 2 new lakes with aquatic invasives in the last 2 years. We're seeing pollution, we're seeing erosion, and we're seeing the gutting of environmental laws around the country. So time is not on our side. We have to work hard and fast. There is legislation sitting around in the legislature on walls and committees that has not moved. And we've been advocating for much of that. And when the session starts again in January, we'll be at the State House advocating again. But we need your help and support. So I just kind of want to do a little, you know, a little pep talk. I know it's summer, but keep that in mind. Time is short. And we need to move. I think we need to move more quickly than we have been. So thank you. So finally, I just want to thank the South Burlington Library and the South Burlington Library staff for letting us use this wonderful facility and being so supportive as we try to learn the technology. I want to thank all of you for your patience when we get started this morning. I'm trying to get started, get everything going. But most of all, I want to thank all of you for your work. So many of you are volunteers and you work tirelessly and donate your time as well as your dollars. And we couldn't do any of this without you. What would our lakes be without all of you? So thank you so much, and thank you for your support of the Federation. And with that, we are adjourned.
Membership forms.